Hey guys, I hope you're doing great today. I'm really super excited because today we are going to start about Docker. Docker is one of the most important DevOps tools that is used in every IT company. Whether it is a startup or a large organization, their infrastructure uses Docker to run their applications. So whenever we are talking about the DevOps tools, you should have Docker in your mind. And guys, honestly, Docker is one of the simplest DevOps tools that you can learn real quick. And I am super excited because we are going to start with Docker today and we are going to learn a lot about Docker in this series. So I have named this playlist as Docking Docker to Your Mind because I want to dock Docker to your minds and you should have every concept about Docker cleared. So in this chapter today, we are going to start with Docker, Docker architecture, Docker terms and tools like what is an image, what is a Docker file, what is a Docker container, what is Docker Hub, what is Docker Registry. So these are a couple of terms that we are going to use extensively in our upcoming lectures. So we are going to discuss these terms in this lecture today. So let's get started. So in order to understand Docker, simply we take the example of this huge ship with thousands of containers on it. So you might have seen this ship with hundreds and thousands of containers docking from one seaport to another seaport. And each container is isolated and packaged with different stuff like fruit, garments, vegetables, rice, etc. It could be anything in these containers. All these containers are isolated and can be shipped from one place to another in the world. And that's the same thing as what is Docker in the cloud computing world. Now let's relate this example of ship with containers with Docker that we run in our server. So the Docker is a platform for developing, running and shipping applications. The Docker engine is the big ship that runs in the sea. It manages all the containers. Docker is also known as an open source containerization platform. And Docker enables you to package your application into a bundle known as a container. So this Docker engine manages all these containers. So without a Docker engine's containers cannot run. So Docker engine plays the crucial part. Docker engine helps us to manage all the containers. Without this Docker engine, we cannot ship or run containers. So just like ship, Docker engine plays the most important role to manage all the containers. Also, Docker engine helps us to push and pull the Docker images from the Docker Hub registry. You can also see that all these containers are isolated with different packages. And the most exciting part is that when your application is packaged into a container, it can be shipped and deployed anywhere in the world. So guys, Docker helps us and makes it easy and simple to run, build, and deploy and manage containers. So guys, Docker has drastically changed modern IT infrastructure. Docker was introduced back in 2013 and it has been bringing so much excitement in the IT world ever since. Docker has changed the way of application deployment. Developers and DevOps engineers love Docker because it provides all the facilities to run their application, whether it is a dev environment, it is a staging or a production environment. You might have heard about CI/CD, continuous integration and continuous deployment. And Docker plays an important role when we talk about CI/CD. And Docker enforces automation in the building, testing, and deployment of applications. Additionally, Docker is a comprehensive end-to-end platform that includes UIs, CLIs, and APIs, and security mechanisms that work together across the entire application delivery lifecycle. Fortunately, many cloud hosting companies offer a built-in Docker deployment strategy. So that was a brief overview of Docker. Now let's see what is the Docker architecture. Docker is based on client-server architecture. When Docker is installed on your system, a Docker daemon runs, builds, and distributes the Docker containers. So during the process of running a container, the Docker client talks to the Docker daemon. Now let's draw the Docker architecture diagram so that we can better understand how the Docker works. This is our client. It means that this is you. The client is you. What does a client do? A client builds, pull, and runs the images. I'm a client, I will build, pull, and run Docker images. But the question is how? How I know where did I get those images from? Here, the Docker daemon will help us to find the exact images that we are looking for. So, here comes the Docker daemon. So, this is our Docker daemon. This is my client. So the Docker daemon is installed on your VM, let's suppose, which is your host, right? So this is our host or VM where our Docker is installed and the Docker engine is running. So that part will be played by you. The client is you, right? So when we run a command like docker build, docker pull, or docker run, it sends a request to the Docker daemon. A request is sent to the Docker daemon. Now this Docker daemon is actually running on this host or VM. API. So the client sends a request to the Docker daemon via an API. Now what Docker daemon will do? So we know that part now. We run a command like docker build, docker pull, or docker run. An API sends a request to the Docker daemon. Now the Docker daemon actually does the math behind all the containerization process. So what does Docker daemon do? The Docker daemon plays man in the middle role and it pulls the images from the registry. Now a registry is a place where our images are hosted, like hub.docker.com, which is a registry, image registry, and the Docker daemon will pull the images like Ubuntu image or Nginx image. So you can see that now the Docker daemon is talking with the registry and at the same time it is talking with the client. When client sends some request via an API, it processes and it checks for the images from this registry, and those images are pulled here on your host, on your VM. I have those images on my VM Ubuntu, and then for example I'm running the docker run command, then this Docker daemon executes that command into the containers. I have those containers running on my server or host, container 1, 2, 3, and so on. So that's how, guys, the Docker actually works. This is the main general architecture of the Docker, and you see that you're the client, you run a command, and via API this command reaches through the Docker daemon, which processes and checks for the images. Those images are pulled from the registry, and then when those images are pulled, these images are run into the container, and all this is handled by this Docker daemon. So if you're that's basically the big ship. This is the ship that manages and controls everything, and it checks for the client requests, it checks for the images, and runs those images into the containers. So let me repeat again. Client is you. You are the client. You are running that command. You are running docker build. You are running docker pull or docker run, and so on. then this command is processed via the API and reaches the daemon. Docker daemon checks out which image is required to be pulled, and then it talks with the registry. Then there should be images in the registry, and those images, the required images, are pulled, and we have those images on our host, on our VM. And then, for instance, the command is docker run. That docker daemon runs and executes this command, and our containers start running on our host. So that is the general Docker architecture, and I hope that it should be clear to you now that there are three parts: client, host, and registry. Client is you, host where our Docker daemon is running, the registry, it can be your local registry, but let's suppose we consider it as hub.docker.com where our images are stored, ECR, Elastic Container Registry, and those required images are pulled on our VM, and then the commands are executed into containers. Alright guys, now let's talk about what is a Docker container. Don't worry, we will discuss everything. What is a registry in detail, what is a Docker image, what is a Docker container. Now let's talk about the Docker container. Docker container. You can assume a Docker container as a running process on your system. This is just a simple process. You can assume it to better understand it. However, these processes are isolated. Guys, this is the main and important concept. You have to remember that the Docker containers are isolated. They have nothing to do with each other. Container 1 does not know what is inside container 2. Container 2 does not even care about container 3 because they're all isolated. So that's the main concept. Containers are isolated and they use the kernel of the operating system, and Docker daemon manages all that stuff, as you know now. So a container is not just a process. A container contains an entire runtime environment, and it shares the operating system, it shares binaries, it shares libraries wherever needed. A Docker container is built from a Docker images, and when we run a Docker image into a container, it pulls all the binaries, libraries, and all the dependencies that are needed to run that container. So all these necessities like binaries, libraries are bundled into a single package, which is an image, and when we run that image, it becomes a container. And guys, we will also check when we will access any running container via SSH, you will see that a container contains the complete setup of a Ubuntu or Debian-like server. For instance, we checked the directory structure of a Ubuntu server in our Linux file system chapter. Similarly, when we access any running container, like we access the Ubuntu container, it will contain the full architecture of a Ubuntu-like operating system. So in short, a container is the smallest footprint of any operating system. So guys, that's the beauty of the Docker system. For instance, this is my host and it runs Ubuntu. So on this host, I have Docker installed, right? And I can use Docker daemon to run multiple containers on this single host or single VM. So this Ubuntu host with Docker installed, it can run, the Nginx container, right? The Apache container, the Alpine Linux container, Debian container, Java, Node.js, and so on. That's the beauty of Docker. We don't have to care about the underlying operating system. So we can run Nginx, Apache, Alpine, Debian at the same time on a single VM. And that's the beauty of containerization. You don't have to worry about the environment. Now I hope that the concept of Docker container is clear. Now let's talk about a couple of Docker terms that we will extensively use in our upcoming lectures. Docker terms that we must know. So guys, if you're going to work with Docker, you must know these terms and terminologies. What are those terms? Let's discuss them one by one. So the first term is obviously Docker. I have another definition of Docker. It is the babysitter of all containers. It watches all the containers and make them healthy and keep them running. So Docker is the babysitter of your containers. And also Docker pulls the images from the Docker Hub registry and runs them into the containers. And your host, which is running Docker, is the Docker daemon that does all the math behind running containers. And now the second term is, what is a Docker image? This is a general overview of all these terms. The Docker image is the bundled, a packed package which contains all the libraries and dependencies to run that image into a container. Docker images are also known as artifacts, and each Docker image is pre-packaged with all the necessities. For instance, let me share an example of the Docker image of Node.js. So this Node Docker image will definitely have all the libraries and binaries to run the Node applications. Similarly, it goes for Nginx, Apache, Ubuntu, Alpine, etc. In Java, all those images have pre-built libraries and dependencies and versions packaged into a bundle known as Docker image. And guys, it is so simple to pull image like Docker pull node. Yes, that's the command. Docker pull node. And we will have the node image on our VM, on our server, on our host. One of the most beautiful things about Docker images are they are very small in size. For instance, like I talked about Alpine Linux image is as small as 5 MB. Yes, it is just 5 MB and we can run Alpine Linux into a container and it will take only 5 MB. Yeah, that's Docker. Now the third term is Docker, guess what? Container. So Docker container is the running form of a Docker image. It is an isolated process and we can run multiple containers on a single VM. We will definitely use a Docker image to run a Docker container. Each Docker container requires a base image which acts as the base, and then multiple layers are built on top of it to run a complete container. The Docker containers are isolated, but it does not mean that they cannot talk with other containers. If all the containers are on the same network, they can communicate with each other. But the main requirement is that they should be on the same network so that all those containers on the same network can talk to each other. Alright guys, the fourth term is Dockerfile. In Docker, the thing that I love the most is Dockerfile. Dockerfile is a blueprint to build Docker images. It is a simple file with a set of instructions like add, copy, run, cmd, entry point, and those instructions are written in an organized form into a Docker file, and we run Docker build command which checks and reads the Docker file to build the images of our own choice. And guys, this is the syntax of Dockerfile. Dockerfile always written in Dockerfile in simple text with D capital. The Docker daemon reads this file, Dockerfile, to build the Docker images. And we can modify our Dockerfile to build and change the Docker images. So Dockerfile is one of the key requirements when you have to customize your images. Alright guys, number 5th term is Docker Hub. Docker Hub, or it is also known as the Docker Registry. The Docker Registry. The Docker Registry is the image storage point where you store your images, where you keep your images and pull them when you need them. So the Docker Registry is organized into the Docker repositories. Those repositories can be private and public. You can have your own Docker registry where you can keep your images, and the Docker Hub is actually provided by Docker, and Docker Hub is a free registry to keep your images, but with a little limitation. You can have only one private repository and have unlimited public repositories to keep your images. But as a beginner or as a DevOps engineers, I would strongly recommend to play with hub.docker.com. You can type it on your browser and you can create a free account. We will do it, by the way. So Docker Hub or Docker Registry is the storage point where you keep your images and you pull and push your images to and from the Docker Hub or the Docker Registry. So guys, in Docker Hub or Docker Registry, I told you about a private repository and public repository. So what is a Docker repository? So a Docker repository is the set of multiple Docker images with the same name but different tags. I mean, this is my image. Okay, this is the tag. Don't worry, we will have a full lecture on Docker tagging. So this is my image, and I can have multiple versions of this image: version 2, version 3, version 4. So you can see that my image, my image, my image. The name is same, but the tags are different. So these are all tags, right? These are Docker tags, and this is the name of the image, which is constant Docker image name. So that's where a repository plays its role. It keeps the multiple versions of Docker images, and we have to create a Docker repository to keep all those images. So on Docker Hub or hub.docker.com, you can create one private repository and multiple public repositories to keep your images with different tags. That's the purpose of a repository. We will create a private and a public repository, and we will test how we can push certain images like these images with different tags to hub.docker.com, how we can pull those images on our host or VM. So that's the purpose of the repositories. The repositories keep multiple versions of images, and for instance, if I have Node, I can create the different or separate repository for Node images. I have Java application, I can create different repository, a new repository for Java images. I have Nginx and so on. So that's where the repository plays its part, and it's beautiful thing, honestly. So these are some of the most famous and most frequently used Docker terms that we will use in our Docker lectures, like Docker server or Docker daemon, Docker images, Docker containers, Dockerfile, Docker Hub or Docker Registry, and Docker repositories. So I hope that you have an overview knowledge of all these Docker terms. We will be working on each Docker term in detail. We will be installing, definitely we will be installing the Docker daemon. We will pull and push Docker images and run them into the Docker containers. So that was our first lecture about Docker. Docker is really an easy tool and that can be learned real quick. So you saw that we discussed about Docker, what is Docker, and we discussed the Docker images, containers, and we had a general overview of the Docker architecture where a Docker client talks to the Docker daemon, and then this Docker daemon pulls and pushes the images and we run them into containers on our host or on our VM. We will have the lab sessions where we will practically see this with our own eyes, that how the Docker images are built and how we can run them into containers. So that was our first lecture of this Docker course. That would be a full Docker course where we will be talking from the very beginning concept to the advanced concepts. So today we discussed the beginnings of Docker. In the next lecture, we are going to talk about what is Docker used for? What are the uses of Docker and how the IT companies and organizations are using Docker to run their applications. I hope that you liked this lecture and you liked this conversation. And these were all simple and basic concepts about Docker. But still, if you have any questions, please comment down. And I really appreciate if you subscribe my channel and share the video among your circles. In the next lecture, we are going to talk about what is Docker used for, what are the uses of Docker, and why it is necessary for a DevOps engineer to learn this tool. So I will watch you guys in the next video. Till then, please make sure to subscribe my channel DevOps Molvi on YouTube, and see you in the next video. Hey guys, I hope you're doing great today. This is our chapter number 10, in which we are going to discuss about what is Docker used for. Guys, in the earlier lecture, which was our chapter number 9, in which we discussed about what is Docker. And also we discussed a couple of terms that are used in Docker, like Docker images, Docker containers, Docker Registry, Docker Hub, etc. So that was actually a brief overview of Docker. In this lecture, we are going to discuss about what is Docker used for? What are the benefits of Docker containers in IT firms and in IT organizations? And we will also have a quick look on which companies are using Docker to run their applications. So that would be a little short and quick video. So let's get started. So my fellas, we all know that Docker has reshaped the IT industry, right? And now we have that basic knowledge. What is Docker used for? It is used to build, run, and ship applications anywhere around the world. Docker is used to package the libraries and binaries and other essentials to run an application into a bundle known as a Docker image. Then we run this Docker image into a container. And we know that container is a running process. It is your application running as a process in an isolated container. So that was just a quick revision. We discussed about it in our last lecture in detail. Now let's talk about a couple of benefits of Docker. Guys, Docker is the worldwide choice for containers. And the most beautiful thing is that you can run a CentOS or Cloud Linux container on a Ubuntu VM or a Debian container on Alpine Linux. Docker containers are fast to build and easy to deploy. Docker has two core components known as Docker Engine and the Docker containers communicating with each other for the smoother application deployments. I was going through the internet and I was searching for the companies that are actively using Docker in their IT infrastructure. And guess what? I found the big names like PayPal, New York Times, Google, JP Morgan, Chase, AWS, Azure, and Google Cloud Platform, and so on. The list is so much longer that you can't even imagine. Which means that Docker is now everywhere. Now we know that how can we deploy our applications using Docker containers, but we need to understand how the applications were deployed before. And guys, after knowing that, you will fall in love with Docker much more, because the Docker has made the lives of developers, software engineers, and DevOps engineers really easy. So how applications were deployed before? It was one of the hardest thing for the developers to run their applications on production servers. And there was no such concept of continuous integration and continuous deployment, known as CI/CD. So I was talking with one of my friends who was working as a Java developer in an IT company when there was no concept of Docker or automation. And he told me that their application deployment was a lengthy, slow, and time-taking process. Additionally, he told me that more servers infrastructure was required to deploy their applications. And the worst part was that if a server was dedicated for Java application, for instance, this was a server only for Java application, we needed another server for Node application. And guys, now it is possible using Docker to have Java or Node applications on the same VM, on the same server. So that was happening before Docker. We needed a separate server. If we had Java application, we needed a separate server for Node application and for PHP, etc. And it was increasing the infrastructure cost, because you have to invest in server infrastructure to have separate server for your separate applications. And now we can have a single server where we can test our Java application or Node application or a Laravel application. But when the Docker platform was introduced back in 2013, that manual process of deploying applications has been dead ever since. So guys, Docker has helped to promote the trends towards microservices and containerization in software development. And therefore, Docker has saved millions of dollars for companies in infrastructure costs. So long story short, we can now deploy Node application, Java application, or PHP application on a single server with isolated containers. So when there were 3 servers required, we can do the same job on a single server or a single VM. That's the huge benefit of Docker, and we don't have to worry about the environment settings on our Linux server. And Docker has made all that possible. So guys, from this conversation, what did we learn? We learned the 3 major benefits of Docker. The first benefit of Docker is easy usage. Docker is open source, and therefore guys, you can learn it real quick. You can install Docker on Linux, Windows, or Mac OS and start working with Docker on the spot. And the Docker commands are real simple. For instance, if you want to have a Ubuntu container running on your VM, you just need to run this simple command, docker run Ubuntu. And guys, honestly saying, you will have a running Ubuntu container on your VM. So the Docker platform is really easy to use, and fresh DevOps engineers can quickly learn Docker even on their VMs. And that would be our next part, to install Docker on our VM. The second benefit of Docker is easy deployment. So a Docker container can be deployed easily in the cloud, and Docker in particular makes it really simple and easy to build the local development environments that function just like a live server. So you can have the replica of your live applications on your local VMs using Docker. So the organizations that have been using Docker for their CI/CD deployments have reported 50% less time running their applications using Docker. And that's our next benefit, that Docker speeds up the deployment process. It is simple, simplicity, and speed. So guys, if you are asked about the advantages of Docker in any interview, You can tell them the easy usage, the easy deployment, simplicity, and speed with the Docker platform. And therefore, Docker is well known for its ability to streamline the process. Because of the simplicity, Docker is compatible with large types of environments. So, what does this mean? Whether you have any kind of application, you will find a Docker image for that application. Whether it is a Flutter application, a Node application, Java, Magento, Vue.js, and so on. And you will find the relevant official images on Docker Hub. So in order to build up a standalone environment for your application, Docker speeds up the deployment process and you will have a fully functional environment in a couple of seconds on your VM. And the fourth benefit is continuous deployment and testing. So guys, Docker makes it possible to have consistent environments from development to production, and it's really easy in Docker. For instance, a developer has to upgrade a product through its release cycle, and in that case, he can do it by making the necessary amendments in the Docker container, and he can test them and implement all those changes in the running containers. Also, finding relevant images in Docker is really simple. We have Docker Hub, hub.docker.com. We already discussed it in our Docker lecture, where we store images in our public or private repositories, and that Docker Hub is used to share the images with your team. So with Docker, the deployment and testing lifecycle never breaks. The last and most concerning benefit of Docker is multi-cloud platform support. Yes guys, whether you are running AWS, Google Cloud Platform, Oracle Cloud, or Azure, Docker is portable, which means that Docker is supported on all these cloud platforms. And that's why guys, portability is one of the Docker's primary selling points. And by the way, there are separate services, like there is Elastic Container Service on Amazon. There are registries for Docker images on Google Cloud Platform and on Azure. So which means that Docker is supported and used on all these cloud platforms. So these were 5 major benefits and advantages of Docker. Its easy usage, easy deployment, simplicity, and speeding up the software delivery process, continuous deployment and testing, a cycle that never breaks, and multi-cloud platform support. Whether you have GCP, AWS, or Azure, you never have to worry about Docker support. Docker is supported on all these platforms and it runs everywhere in the world. So guys, now you must be concerned about the companies which are using Docker for their IT infrastructure. So I have Googled it and searched the following companies that are using Docker to run their applications. So the companies that are powered by Docker are Airbnb, Spotify, PayPal, Uber, Netflix, BBC News, New York Times News, and so on. The list is huge, and all these companies rely on Docker to power their infrastructure. Alright guys, that was a little short and quick tutorial about Docker usage, what is Docker used for. In the next chapter, we are going to install Docker on our VM so that we actually start with practical labs on Docker. Since we already covered Linux commands, we covered like 75 basic commands, so you must have a grip on CLI. And we are going to use the Docker commands to build, run, and ship containers. And guys, one of the interesting facts I wanted to tell you that if you know basic Linux commands, then it is easy to quickly get your hands on Docker commands. Because, for instance, if I use cp command to copy files on Linux VM, then the command in Docker becomes docker cp. So the docker cp command is used to copy files in Docker. Similarly, move command in Linux becomes docker move, and so on. So that's why it is mandatory to have a strong grip on Linux shell. So in the next chapter, we are going to install Docker on our VM, and then we are going to learn Docker and its commands and how we can build and run Docker images into containers. And that would be a full free DevOps course on Docker. So I would really appreciate if you subscribe my channel DevOps Molvi on YouTube and support the channel. I will see you in the next chapter. Hey guys, I hope you're doing great today. Well, in this tutorial, we are going to install Docker on our Ubuntu 22.04 machine. So guys, there are two methods to install Docker on your VM. The first is we can install it with apt install docker. The other method is to install the fresh or the latest version of Docker. So let's get started and install Docker on our VM. So guys, I have prepared this short tutorial guide how to install Docker on Ubuntu 22.04. And don't worry, I will share it with you guys. The link of this tutorial will be in the description. So you can see that the installation is divided into 5 steps. The first is update the software repository. The second one is download tools and dependencies. The third one is to add Docker's GPG key. Each step is written with its explanation. And after that, we will add the official Docker repository so that we can install the latest version of Docker on our VM. And then we will install Docker. So let me log into my VM. So I hope that now you are comfortable working with the CLI or command line or shell. DevOps Molvi is my user, and you can see that I am authenticated with my keys. So we can log in to root just to see. So I was checking Docker installation here, and you can see that Docker and apt install docker.io, and it will install the 24.0.5 version of the Docker, which is I think an old version. And let's check what is the current version now. Current version of Docker, and you can see I just checked it yesterday, to be honest. And what is the latest version of Docker? And the latest release is 27.0, and it was released 1 week and 5 days ago. So that would be our latest version of Docker, and I think we should install it because the latest version comes with a lot of fixes and other things that are updated. So we should avoid installing an old version. So but for your learning, you can install, and it is one liner install. You just need to run as root or sudo with DevOps Molvi. We will be running our commands with DevOps Molvi, of course. And you can see it is just one line command, and Docker will be installed on your system with 24.0.5 version. But if we want to install the latest version of Docker, we should be installing with that guide that I will share with you guys. So I will exit, and we can check. You can see that the Docker is not installed on this VM, and it is also saying that you can use sudo. With root we can directly install with apt install, but on DevOps Molvi user we have to run sudo apt install, and you can see that the same version we can install with apt install. But now we are going to install the version 27.0, with the following steps that I've mentioned in this document. So I hope that you don't have any confusion. This is the latest release of Docker engine, uh, and we are going to install this release. So it is recommended that we should install the final or latest version. And I hope that you have enabled virtualization on your Windows computer, installed VMware Player, and running Ubuntu on it. We have already done all these steps, and now we are going to install and run our first command, which will update the software repository. Sudo apt update, which is one of the most common commands, and it is used to update the software repository. I will run it with sudo, and it will ask password. Oh, it didn't ask for the password. Now our software repository will be updated. It will take a few moments. All right, guys. Uh, After running that command, I will clear my screen. So the next step is download tools and dependencies. It is also a mandatory step because it will install a couple of software tools for encrypted communication. We are going to talk with the Docker and software repositories. We are going to download them. I want my communication with repositories or with the links that we are going to use in the commands should be encrypted, and for that it is important from security point of view. I have written it in the document, and it is recommended to transfer the data and files using apt transport HTTPS to keep the environment secure. So we will install these tools so that our communication with external sites must be secure. And I will just run this command. You can see that there are a couple of softwares we are going to install: apt transport HTTPS, CA certificates, curl, software properties common. So these are tools recommended by the software developers and engineers so that your communication must be secure, and it will take a few moments to install. Apt install is a heaven. It is one of the most simplest and one of the easiest command to install any kind of software on Ubuntu. You just need to install apt install NetTools, apt install Apache, apt install Nginx, apt install docker.io. So that is one of the most easiest command you could ever imagine. So guys, it will take few moments. Our progress is 80% now. So let's see what is the next command so that we can continue without wasting our time. And it is add Docker's GPG key. And what is a GPG key? It says that it is an excellent method to ensure secure communication between two parties, because we are going to pull to get to download the software from the third party, and it protects the package against tampering. GPG relies on a security concept known as public key encryption. When you add a key with apt key add, you trust that the key to authenticate software. Because we are going to install Docker, that's why we should avoid any malicious thing, so that our system must not download any malicious software or malicious package. That's why we add the Docker's GPG key. You can see it is the following command, and it will add the following Docker archive keyring.gpg key. And the purpose of this GPG key is to ensure that we securely communicate with the following site. You can see that we are going to download from this site, download.docker.com, and we are going to install this GPG key, and curl command is used to do so. Clear. And I will run this command, and it will add the docker GPG key. Yes, I will overwrite it because I downloaded it a day before, and clear. So our GPG key has been added. Now we will add the official Docker repository from where our apt install docker command will pull the packages, and we will have a latest version of Docker software installed on our VM. Now this command is used. I will copy, and you can see that it is saying we are going to install Docker's stable release from its official repository. So download.docker.com is the official repository, and since our VM is Ubuntu, we are going to install the tool, the Docker software for our Ubuntu. Therefore, we have to add that repository to our system. And now I will just add the repository. That repository should be added here. You can see etc apt sources.list.d. We can go to this side. Okay, the directory is here. Now you can see that this docker.list sudo nano docker.list must have this archive from where we are going to install our Docker. So here is the repository link, and we are going to install Docker from this latest release. And now I will update my repositories, sudo apt update, and you can see that it is now updating the repositories. So it has been done. Now we have to run the final command to install Docker on our Ubuntu 22.04 VM. And guys, if you have 24.04, the method would be almost the same. And we will be installing Docker CE. So there are actually two editions of Docker. The first is Community Edition and the Enterprise Edition, which is the second one. So we are going to install Community Edition, which is free, and it's around 504 MB download. And yes, that's true. And I will run this command to install, and we will see that whether we are having the latest release of Docker installed on our VM. So it is saying that after this operation, 437 MB of additional disk space will be used. Okay, I will click yes, and now it will take a few moments to install Docker on our VM. So guys, the installation is still in progress, and you can see that it will take 2 minutes to install. We can review our Docker installation guide. So there are only 5 steps you saw, and in which we updated the software repository first, and then we installed a couple of security tools which are used to communicate securely over HTTPS, which is encrypted. And then we added the Docker's GPG key for more security, and then we added the official Docker repository. What is the purpose of adding official Docker repository? So that we have the updated release of Docker on our VM. And then we again updated the software repository, and we installed running the apt install Docker Community Edition, which is CE. So in order to avoid that much steps, you can just simply run apt install docker.io. But the only difference is that it will install the the older version of Docker, which is 24.0, and we are using this method and executing 5 additional steps so that we can have the latest release of Docker on our VM. So it is your choice. You can directly run apt install docker.io. Guys, you can see that the installation is now in progress. We have downloaded, you can see the packages downloaded in apt install docker. We can see the docker ce and also other tools like CLI and also compose plugin and so on. Now it is being installed on our VM, and you can see that the version we are installing is 27.0. We can see in the installation logs all these logs are showing the packages that are required and also uh, the plugins that are needed to run Docker are also getting installed, and our Docker installation has been completed. So I will run Docker to verify whether our installation has been completed. And guys, we have our installation of Docker completed, and you can see that, and we are able to run the Docker commands. You can see that it is a self-sufficient runtime for containers. So Docker is installed. Now we are going to run our first command, and it is a normal general command to run and confirm whether our Docker installation was correct. Docker run hello world. And the purpose of running this command is to get this error, and it is saying that permission denied while trying to connect to the Docker daemon, and we are not able to run this command. You can see Docker images, and I'm getting the same error, Docker search Ubuntu, and I should be getting this error. So how can we fix this error? And the error is literally very simple. And you must get this error while you complete the installation of Docker, because I am using DevOps Molvi user to run the Docker command. So this error is saying that DevOps Molvi does not have the permissions to run Docker command. So I have to grant DevOps Molvi user the permissions to run Docker command. So there must be a Docker group. So first we should check sudo nano etc groups, and there must be etc group, and you must be able to see the Docker group. You can see it is just recently added, and I will add the DevOps Molvi user into the Docker group so that DevOps Molvi user can execute all these commands, all the Docker commands. And guys, if I go to root user, I would not be getting this error. Let's try for our learning. Sudo -i, and now I am in the root. All right, are you getting my point, right? So now I'm in the root, Docker search images, and you can see I am able to run this command, and Docker search nginx. I'm not getting any of the permission denied error. You can see we are able to search any image, nginx image. So I would be able to run any command using the root user, because root is a super user. But I want to run Docker commands with DevOps Molvi user, and I Docker search nginx, and I am getting this error. So if I use sudo, then I should not be getting this error, because DevOps Molvi is a super user with sudo, but I want to run without sudo. So the fix is simple. We would be adding sudo user mod minus a capital G. We have used this command. If you remember, we used this command to add multiple users into a single group. So this command user mod minus add group Docker and DevOps Molvi. Alright, you can see that now I am modifying the user DevOps Molvi and adding it into the Docker group. Again, let me repeat it again. I'm modifying user mod command and I want to add DevOps Molvi user into the Docker group. I have shown the Docker group in etc group. You saw the Docker group was added, and now if DevOps Molvi becomes the part of that Docker group, it will be able to run all the Docker commands without sudo, without any privileges. And now let me see the etc group file, etc and group, and you can see our DevOps Molvi user has been added into the DevOps group. So guys, we have learned a couple of things from this practice. First of all, we saw while installation of Docker was completed, and then a Docker group was available in etc group file. You can see this file, and we were not able to run any Docker commands with DevOps Molvi user if we were not using the sudo. And I want that my user can be able to run all the Docker commands without sudo. And we encountered the above error which says permission denied. So the fix was literally so much simple that we had to modify the DevOps Molvi user and we added it into the Docker group. I'm sure that this detailed explanation will clear the concept. So guys, now our DevOps Molvi user has been added to the Docker group. Now I should not get any errors while running Docker run hello world. So I'm running this command without sudo and I want my command to successfully run. Oh no! What happened? You can see that I'm getting this error again, so we'll have to fix it. So the fix is I will log out from this terminal and I will try to log in again. This is a troubleshooting step, you can say, and DevOps Molvi, and I have to authenticate. Now Docker run hello world, and it is running without sudo on my VM, and it is saying that unable to find image hello world latest locally. So guys, now there was no Docker hello world image on my VM, and what it did, it pulled the image. You can see that this is the hash of this image, Docker run hello world, and it downloaded the newer image for hello world latest. This is the tag, this is the image name. So hello from Docker, this image shows that your installation appears to be working correctly. To generate this image, Docker took the following steps. Guys, this is literally very important to read these lines for a beginner. It is saying what is happening behind the scene. And the Docker's client contacted the Docker daemon. We already discussed in our what is Docker lecture. I ran Docker run hello command, hello world, and the Docker client, I was the client, right? And I contacted with the Docker daemon, which was installed just a couple of moments ago, and then the Docker daemon pulled the hello world image from the Docker Hub official repository. Now we have to check hello world image if it exists on Docker Hub. So I will type hub.docker.com and I will try to find if there is hello world image, and there should be one because it was pulled from this repository. This is repository, and we are going to create an account because we are going to push and pull our images to this repository, which is hub.docker.com. And I will search hello world, and you can see the image is there. This is official Docker image and has 1 billion plus pulls. Wow, there has been more than a billion pulls of this hello world image, and you can see that I ran docker run hello world, and in order to pull the image only, the command is docker pull hello world. And you can see it must have a tag which is latest, and we can find the latest tag by filtering. You can see this was the tag that we pulled from hub.docker.com. So guys, any official image, it is available in Docker Hub and it is pulled from that image. Now back to the terminal, you can see the Docker daemon created a new container from that image which runs the executable that produces the output you are currently reading, and the Docker daemon streamed that output to the Docker client which sent it to your terminal. Now we can run a Ubuntu container with docker run -it ubuntu bash. This command is used to run a brand new Ubuntu container. So guys, now I want to check whether I have this hello world images on my VM. I will clear the screen, Docker images, and you can see that I have this hello world image that was downloaded while I ran the Docker run hello world command. So it means that our Docker installation is perfect and everything is looking smooth. So we can find or pull docker pull Ubuntu latest. Now it will pull the Ubuntu latest image only. It will not run the image. So we are going to pull it and it will take a couple of moments. And it is saying that latest tag is being pulled from this library Ubuntu. Now we can pull other tags as well. For instance, if I search Ubuntu in the official Docker Hub repository, you can see Ubuntu is a Debian based Linux operating system based on free software, and the command that I ran is docker pull Ubuntu. And if I want to yes, this is 24.04, and the tags, we can find out all these tags here, and these are the tags, and I used the latest tag. Every image comes with that tag, and I want to find 24 point, and I want to search this tag, and yes, you can see I am able to find this tag. Now the command will be changed to pull that exact tag, and I will use docker pull Ubuntu 24.04 command to pull that tag. Alright, you can see that our Ubuntu image has been pulled and it has the latest tag. Again, Docker images, and you can see Ubuntu with the tag latest. latest tag, and this is the image ID, and it was created 4 weeks ago with this size. Now I want to pull a specific tag, this one. All right, and what would be the command? The command would be docker pull this Ubuntu with 24.04 tag. I will run this command, and it, it will pull the Ubuntu image from Docker Hub with this tag, and it must have another image with this tag. So clear the screen, and we should have 3 images now. Okay, we have Docker image of Ubuntu with tag 24.04. So that's how, guys, we can pull the Docker images with specific tags on our VM. For instance, if I want to search for Nginx, and this image is also one of the most frequently used image, and you can see it has also more than 1 billion pulls, 1 billion image pulls. And this is the command to run docker pull nginx, and there are a lot of tags for this image. And nginx is a web server which is used to run web application, and it is used as a reverse proxy as well. And there must be a latest tag, and there are also a lot of other tags. And for instance, if I want to search latest, and you can see that we have this Ubuntu, Nginx latest tag, and I will run the command like, I will not pull the image, I will directly run docker run nginx latest. So guys, what will this command do? It will first pull the nginx latest image, and then it will run nginx on port 80. We will be having a running web server on our VM. Okay, it is saying that there is no such image locally on my VM. That is true. We don't have this image, and now it is pulling the nginx image from hub.docker.com with latest tag. Then this command will also run nginx on our VM on port 80, which is default, and we would be able to change this port to any other port. Alright guys, now you can see these instructions, these layers. So each layer is a set of instructions. Our Docker images are built on these layers. Alright guys, you can see that our nginx image has been pulled, and it has been running fine because I've used docker run nginx latest command, so it is running on the screen and not running in the foreground. So I can check with docker ps command, docker process show, and it lists the running containers. And okay, you can see that my nginx latest image and the docker container id is this one. So this container is running, and it is up from 3 minutes, and also you can see that it is running on port 80. And also, if I want to inspect docker inspect and docker ps, and I want to inspect docker inspect this container id, and I will get a lot of details of this container. You can see it is running on this IP address gateway, and this docker inspect command is literally a great command which shares all the details of any running container. And you can see that the image was nginx latest, and this is the entry point. And also we can find the image IP where this container is running, on which IP, and we can find this. The IP address is 172.17.0.2. This is the IP address and other details of the container. So that's how, guys, we can inspect any running container. So you saw that we just ran docker run nginx latest. It pulled the nginx image and run it into a container. Guys, that's it for today. Let me repeat, what did we do today? We installed Docker. We installed the latest release of Docker on our VM, and then we ran our first container of Docker run hello world. That was our first container, and we encountered a permission denied error, and we also fixed that. That is one of the most common errors while you work with Docker. And you saw that we added DevOps Molvi user into the Docker group, and that's how we fixed this error. So also we saw Docker images, and we pulled a couple of Docker images from the official hub.docker.com repository, and you saw that all the official images are stored in hub.docker.com, and we can pull any image with the tag mentioned on this official repository. So we can pull Docker images with the latest tags and with the tags of our choice. So these were some of the basic commands, and we just confirmed whether our Docker installation was perfect and working without any errors. In the next lecture, we are going to play with containers. We are going to run multiple containers on our VM. We are going to learn about the common Docker commands. Like you can see, Docker itself is letting us know the common commands like docker run, execute, ps, build, pull, push images, log in, log out. So we will cover all these commands, and these are basic Docker commands to work with the Docker containers, to build Docker images, to push Docker images to official repository. We will have an account created on hub.docker.com in the next lecture. So the next lecture would be a huge knowledge sharing session, and I would really appreciate that if you subscribe my channel. I will watch you and see you in the next lecture of Docker. Take care, and don't forget to subscribe my channel. This is the only way I get support and love from you guys. Bye. Alright guys, now let's start with our first Docker command. So I have been logged in my terminal. You need to log into your VM, and I have been logged in with DevOps Molvi user. So this would be my first command in which I would check the status of my Docker service. Sudo systemctl status docker, and it is asking the password for. Okay, now you can see that Docker application container engine, it is running, and the daemon is docker.service, and you can see that the docs link is here, where you can find the official documents and tutorials of Docker. So this was our first command in which we can see whether our Docker engine is running or not. When we boot our system and we want that our Docker service should be started automatically, then I would have to enable it on boot, and the command for that is sudo systemctl system control enable docker. And now guys, when my system is booted or rebooted hundreds of times, on every restart the Docker service should be running. So if I want to restart Docker service, then sudo systemctl restart docker, and our Docker daemon or Docker engine would be restarted. And also if I want to stop it, sudo systemctl stop Docker, and our Docker engine would be stopped. We can check the status of Docker with sudo systemctl status Docker. You can see that it is dead, and it was dead 15 seconds ago. So we stopped it a couple of seconds ago, and you can see the status is inactive. Now we will start the Docker daemon. Clear, sudo systemctl start Docker. That's the simple command to start our Docker daemon. And now systemctl, guys, if you are beginners and you want to become a CLI or command aficionado, then you must write all those commands by your hands. Okay, don't rely on this up arrow key or down arrow key. You should try to write the whole command so that you remember them forever. Sudo, just like I'm writing the whole command, systemctl status Docker. And now guys, you can see that it is active. So these are some Docker management command, Docker system commands in which we can see whether our Docker engine is running. We can restart it if we want to reflect some changes, and we also enabled Docker engine on our booting system. When our system is rebooted or shut down and powered on, then our Docker engine must run on every boot. So these are a couple of system control commands. Now we will be moving forward to the Docker commands. Control C, and Control C will exit, and our Docker engine must be running. It does not kill the process, by the way. Clear. The very first command of Docker engine is Docker. That is the first command because it is the main command that leads to other commands. Whether you write any Docker command, you have to write Docker before running that command. I think you didn't get my point. For instance, if you want to copy something, then the command would be Docker copy abc to the container. Okay, now if we want to see the stats of Docker container, then the command will start from Docker. The Docker is the main command, and other commands are combined with this command. So every command will start from Docker. So Docker itself is a major command, and you can see it shows a couple of options, and you can find the management commands. These are all management commands, and these are all DevOps commands, and DevOps engineers usually run and execute these commands. Now, for instance, our first command is it would be our sixth command, Docker search Ubuntu. I want to search whether there is a Ubuntu image. Yes, it is official, and you can see Ubuntu is a Debian based Linux operating system, and there are all details, and see the stars. It means that this image is officially verified and it is okay to be pulled. And Docker search Ubuntu. You can search any other image, for instance Docker search Debian, and we will definitely find the Debian official image as well. So similarly, Docker search Nginx, we must be able to find the official build of Nginx. So that's how we can find any desired Docker image. All right, now in order to pull any image, Docker pull Ubuntu, and by default guys, it will pull the image with the latest tag. For instance, I can write latest, and if I don't write the latest tag, it will pull the image with the latest tag. Now you can see using the default tag as latest. So the image you pull was Ubuntu, and the tag which was default one is latest. And if I want to pull any image with another tag, I would have to explicitly mention that tag. For instance, docker pull Ubuntu 24.04. Now it will pull the 24.04 official Docker image, because I am now, this is the tag, guys. Okay, and you can see now we must be having these images on our host, on our VM. Docker images, and you can see we have Ubuntu latest, we have Ubuntu 24.04 images. So docker pull any image is the command to pull official Docker images, or you can use this command to pull Docker images from your Elastic Container Registry or GitHub registry or Azure repository and so on. For instance, if I want to remove this Ubuntu 24.04 image, I don't need it, then the command would be docker rmi remove image. Now Ubuntu 24.04 and untagged, it means that the image has been removed. Docker images, and you can see that I don't have that image. We can also remove any image from the image ID. For instance, if I want to remove the hello world image, and I can use the image ID, docker rmi image ID, and it is saying that error response from daemon conflict, unable to delete, must be forced, image is being used by stopped container this. Now we can find that whether there is any container, so we can use docker rmi -f and this image ID, then -f option will forcefully remove the images. So guys, these are actually, I would love to replicate the errors. If you face such errors, you can quickly fix them. So the purpose of leaving such errors and fixing them in front of you makes me really happy, and that's why I try to replicate as much as errors during my lectures so that we fix them together. And now you saw that that image was used by a running container. The practice is usually we stop the container and then we remove the image, but you saw that I removed the image forcefully, which is, by the way, not a good practice. We must stop the container first, and if we don't use it, of course we don't use it, then we stop the container and then we must remove the image. And it is needed when we have been facing any disk space issues. So sometimes a VM disk space gets full, and there are thousands or hundreds of images downloaded on your host. Now each image, you can see each image is taking some space, and that's why we remove images to make some room, to make some space free. So that's how we can remove images, and that's how we can pull images with proper tags. Okay, now moving to the next command. So guys, we installed Docker with proper commands, and we didn't use the apt install docker.io option. So we had the latest release of Docker, and if I want to confirm whether my Docker has the updated version, then I can run docker version. This command shares all the details of your Docker. You can see it is the community edition and the version is 27.0.3, which is latest. So Docker version is the command which shares all the details about your Docker engine and its version. Similarly, there is another command which is docker info. this is one of the fantastic Docker commands, and we can get a quick and general overview of Docker. You can see the story driver, and we have two containers running at the same time now, and version, context, etc. So Docker info is also a great command to know the Docker infrastructure, to know the number of containers running, get an idea how many containers are stopped, how many containers are in the running state, and how many images we have, and what is the story driver. So we can get all this information with Docker info command. Clear? Alright guys, now let's run our first container. That would be our first container, Docker run Ubuntu. And let's see what does it do. What does this command do? And our container must be running. We can see Docker ps command, Docker process show, and we cannot see any container in Docker ps. So there is another command, Docker container ls, and it shows the same output. So Docker ps and Docker container ls are the same command. Now we don't see any running container. We run Docker run Ubuntu, Docker ps -a is the command which shows us the containers that were executed now but in the exit state. So you can see that it is in the exited state. It means that this container run, but now it is now in the exit state. Let's run Nginx container, Docker run Nginx, and now this simple command will run Nginx, but it will occupy the shell as well, because now you can see it is running, but now our shell has been occupied, and if I kill, then our container must get stopped. So in order to understand this, I will log in to another terminal, DevOps Molvi, and clear. Now you can see that our actually containers is running, but it is not running in the foreground, in the background, and we want to run it in the foreground. Now Docker ps, you can see that our container was up and it is running fine. If I press Ctrl C, the Docker container will stop. Now our Nginx container has been stopped. So Docker ps, you can see that the container has been killed. Now I want to run this container in the background, and I will run it docker run -it interactive -d nginx. Now we will have a running container but in the foreground. Okay, now we have a running Nginx container, and now we can run Docker ps. The container is running. So that was the difference. Should I repeat? Okay, I will kill. Docker kill command is used to terminate any Nginx, any container, sorry. Clear. Now Docker ps, and we don't have any container. Now if I run Docker run Nginx, so the container will run, but it will also occupy the terminal. And now container is running Docker ps, but if I press Ctrl C, the container gets stopped, and I want to have my container running in the foreground. So the command will have a little tweak, which is Docker run -it interactive -d. This -d option will run the Nginx container in the foreground, and now we can do whatever we want to do, and our container will keep running in the foreground. We have a running container, right? Docker ps, and I want to stop it, this container, Docker stop and container id. we can also stop with the container name. This is the container name, that is a generic name that Docker gives the containers, but now we will use the container ID. We can have our own customized Docker container names. Docker stop command will stop the container. Now Docker, you can see that our Docker container has been stopped, but it should be in the, you can see in the exit state, it is saying that your container was exited, it has been stopped. Now Docker start the container ID, and now our Docker container must be running, or we can use the Docker container ls, and it shows the same command. And if I want to permanently stop and kill the container, then the command would be docker rm -f, forcefully terminate and kill this container and container ID, and it will be completely removed from my VM. And if we cannot even see it in the docker ps -a command, you can see now we cannot see this container ID anymore because it was completely removed from the VM. Now I have to run the container again, but it's good for the practice. Docker run -it -d nginx. Now we are running the container again, docker ps, you can see, and now docker restart. 5 seconds ago, now it will be restarted, and docker ps, you can see that it has been up 2 seconds ago because it was restarted. Now you can see that our container is up for 10 minutes, so I will restart it again, docker restart and container ID. Now docker ps, and you can see that it has been up. So there is a difference between the creation time and status. It was first created 12 minutes ago, but it was restarted 3 seconds ago. So that is the restart command. So guys, let me repeat all these commands real quick. We have almost covered 20 commands, and docker version, it shows us the version of our Docker engine. Similarly, docker info, and we get the information about our images, containers, and our operating system. All right, so docker pull alpine, it is a Linux distribution, so that's how you can see we can pull any Docker image. Docker images, the command which shows all the images we have pulled. And if I want to docker images, and if I want to remove any image, for instance, if I want to remove alpine, docker rmi and alpine latest, it will remove. Similarly, if in order to run any container, docker run nginx. So as I told you that our shell will be occupied and it will not run, I mean in the foreground. So I want to run it in the foreground, and the command would be docker run -it -d is the switch nginx, and now we will have a running container px or docker container ls. Both commands show the same output. And then if I want to run, and if I want to see all the containers whether they are running or in the exit state, then docker ps -a. And for instance, if I want to remove this container completely from my VM, then the command would be docker rm -f and container ID. Now I wanted to share a key concept of the difference between docker kill and docker rm command, and it is one of the important interview questions as well. So you guys saw that if I use docker rm -f command and I remove this, and docker rm -f forcefully removes the container, and this is the container ID. I have run this command. Now this command will delete, terminate, and kills container completely. Docker kill will not completely uh, terminate or removes the container. It will just kill or stop the container. Docker kill container ID. Sorry, the complete container ID. Now the container has been stopped. You can see, but it has not been killed or terminated completely. It is in the exit state. So that's the difference between docker rm-f and docker kill commands. Docker stats is the command to check the stats of any running container. Now you can see that running stats of this container. The container ID is this, and the CPU is, there is no load on this container, so it's all good. Similarly, we can use the docker top command to view the usage of any container. So these are just similar commands. Docker stats shows us the CPU and memory consumption of any container, and similarly the docker top, and these are only the processes running in this container. So docker top command is used to view the resource consumption and currently running processes of any container. Now if I want to stop any container or pause any container on a temporary basis, then docker ps, and this is the container ID, docker pause container ID. Now we can see that it is in the paused state, docker ps, and the status has been changed, that this container is in the paused state. And similarly docker unpause and container ID, this is the container ID, and it will start running again, docker ps, and you can see that this container is running. We have the docker images, and I want to see the history of any image. For instance, I want to see the history of this image, nginx image, docker history and the image ID. You can see it shows all the history of any image, when it was created, the cmd command, etc., and the port 80 has been exposed and other details. So this is also a great command to find the history of any image. So guys, now docker ps, and we have a container running with this name. All right, and we can change the container name for better understanding. For instance, docker rename, and this is the container name. We can also use the container ID to rename any container, and my container 1, let's suppose this is the container, and again docker ps. Okay, we have changed. We can rename using the container ID, docker rename this image ID to my container 234. All right, now docker ps, you can see that it has been renamed to my container 234. So that's how we can rename the containers. Similarly, in order to rename the images, docker images, we have these images. The docker tag command is used to rename the images. Now docker tag nginx latest, it must be renamed to our web server version 1. All right, now the original copy of the image will be there. So docker images, you can see that we have the original copy of the image and a new image with our new tag has been created. Now we can rename with the image ID as well. So for instance, this is the image ID, right? Docker tag image ID, and now what's the name of the image that we want to have? DevOps Molvi colon 1.0.2. Okay, that's the tag. And now Docker images, you can tag images using the image IDs. Clear? So I hope that you are now getting better and understanding these simple commands. We have this running container and I want to see the logs of this container. Then the command would be docker logs and container ID. You can see we can see the logs using the docker logs command, and if I want to see the real-time logs, it is just similar with tail minus f command we used in Linux. Docker logs minus f and the container ID, and now we can see the real-time logs of our container. Now guys, if I want to access any container via SSH, what would be the command? For instance, now this is our container and I want to access it via SSH. Then docker exec command minus interactive shell. Now container ID or container name and bin bash, the type of shell that I want to have. Alright, we are now in the containers. That is our container running. You can see this is our container. We are actually in the SSH of our container. We are actually in our container. For instance, cd etc, and I want to see whether we have nginx because it is an nginx container. Nginx, so we have it. Service nginx status, and you can see it is running. So that's good to know, and that's how guys we can access any container via docker execute command, docker exec command. Let me repeat it. PS get the container ID, my container. Let's suppose I will use the container ID now. Docker exec. That's why I ask you to run these commands yourself. Do not copy paste so that you can remember them. Docker exec minus IT means that give me an interactive shell so that I can access the container and I don't face any difficulties. Minus IT is a great switch. And container ID, and let's suppose if I change this type of shell, I just want sh. This is also a type of shell. Okay, now you can see the difference. And exit docker execute minus it container and bin bash. This is more beautiful shell. So now you can see the difference between both commands. One is using the sh shell. This is, we actually get logged into the container but with a different shell. This is a shell. And now this is my favorite, bin bash, and we are in the container, and we saw that our nginx is running. Now if I want to see all the possible details of any container, then the command is docker inspect container name or container ID, and we will have all the possible details of this container in a JSON file. Now this is the information is in the JSON format, you can see, right? And it contains all the information, just like the name of the container is my container 234, the storage driver is overlay 2, and similarly it is a type of JSON file type, and the IP addresses and the ports. So docker inspect is a great command for troubleshooting the issues with the containers. Alright guys, now let's see how we can export any running container into a tar archive. For instance, we have this container running and I want to export this container into an archive. So what would be the command? The tar archive would be an image that we can load again to run any other container. So docker export and container name, right? Docker export container name or container ID and this symbol. Export this container into a tar archive backup.tar. For instance, my backup image or container, my backup image.tar. Okay guys, now we can see my backup image.tar has been exported. Now I want to import this tar file into a new image, and the command would be docker import and the image tar file and the new image name, my new image colon imported. So we can better understand that this image was imported. Now this command will take a couple of seconds and we will have our image. Alright guys, you can see that our image has been imported. Now I will run the docker images command and you can see that we have our my new image and with tag imported, and it was imported 31 seconds ago. Now I can run a new container with that imported image. So guys, that's how the docker export and import commands work. With docker export, we can export a running container into a tar archive, and then we can use this tar archive to import a new image, and that new image can be used to run more containers. So guys, now I want to push my images to the Docker Hub repository. Then I will have to log in to the Docker Hub. First, we should have an account on hub.docker.com. Then we can push our images to our Docker repository. The repository can be public or private. Now you can see this is our Docker Hub, and I have created this public repository Alpine image. We can have the image, the repository name of our choice. Now, for instance, I want to push an image to my hub.docker.com repository. I will first log in. Docker login command is used to log in, and this is my username and my password. You can see I have successfully logged in to my Docker Hub account from my VM. So you can use the Docker Hub credentials, username and password to log in. Now I can push images, but those images must have the tag according to your repository. You can see that I have created a public repository here, and this is my public repository, and we will use this command. So the Docker Hub shared a command that if we want to push any image to this repository, we must use this command. Now guys, this is the Docker push command, and that is our image name with tag. So we will use the Docker tag command. I will use Docker tag, and I want to use this image Docker tag imported to a new image name according to our repository, which is F-Rahman Alpine images. So I want to have all my Alpine images with different tags in this repository, and colon version 2. You can see I have the version 1 already in my repository, and I will name it version 2.0. Now Docker images, my image has been tagged according to the repository name. This is mandatory because the tag is not according to the repository name, we will not be able to push the images. Now I will use the docker push command. Docker push, we are already logged in because we used the docker login command and shared the credentials. So alright guys, the image has been pushed to our repository. Now I will refresh my public repository on hub.docker.com, and we must have the version 2.0 image in our repository. Alright guys, you can see that it was pushed in a few seconds ago, and we have the tag version 2.0 of this image. So that's how guys you can push images to hub.docker.com. After pushing the images, we can use the docker logout command to log out from our repository. And now you can see that our credentials have been removed. In order to log in back, we will use the docker login command and it will ask for the credentials again. Now for instance, if I want to copy this file into a running container, then docker ps, I have this container ID, and I will copy this package.json file into the running container. Docker cp command is used to copy package.json file. Docker copy file name and your container ID, and where do you want to copy this file. So for instance, if I want to copy it to like usr user share, it says that our file has been copied to this directory. Now I can confirm this file and I will log in to the container docker exec -it. That's how we can revise the commands as well. And container ID bin bash. Okay, now cd usr user share and ls-l. We can see that this file has been copied from our computer. So docker cp command is used to copy any file. Alright guys, now let's discuss some network related commands. Docker network ls, and it shows all the networks of Docker, and I can create a new network using docker network create my network. You can see docker network ls, a new network with driver bridge has been created. Now I can run a new container using this network, and the command would be docker run -it -d network my network. So I will use the new network, my new network, and I will spin up a new container. All right, and ubuntu bin bash, there would be a new container, and this new container will be attached to my new network. Alright guys, we have this container docker ps, and you can see it was spinned up 6 seconds ago. Docker inspect container ID, and I will inspect and see whether it is using my network. Okay, you can see that the networks it is using is my network. Okay, so that's how we can use the network while running new containers. For instance, if I have a running container, now docker ps, all right, now I want to connect this container, I would use docker network connect my network, network name, and your container ID. So this container is now on my network. So similarly, we can inspect again, docker inspect, and it should have network, my network. So now I want to disconnect this container, then the command would be docker network disconnect my network, network name, and the container ID. So now it has been disconnected. For instance, I don't need this network anymore. Docker network ls, and I want to remove this network. The command would be docker network remove. Okay, docker network, every command involves network. Docker network ls, docker network create, docker network connect, docker network disconnect. So similarly, docker network remove and my network. All right, we have removed, and now I will run docker network ls, and there should not be any network with this name. So that's how, guys, we can use the docker network commands. Let's go through some docker volume commands, and let's see how we can create a volume. Docker volume ls, and there is a volume that was created. I was just testing, and similarly I can create a new volume, docker volume create second volume. So a new volume has been created. Now I can mount this volume to any running container. Sorry, docker run, I will run a new container. Docker run -it -d -v would be used to mount this volume. And let's suppose if I want to mount it in opt my data, and the image name bin bash. So we will have this volume mounted in the container on this path. Okay, and without this option, without this switch, we cannot mount any volume. Now I will run this container, and you can see docker ps, I have this container, and I will check whether our this volume was mounted or not. Docker exec -it and bin bash cd opt, and there must be a data, my data folder. So you guys can see that that's how we can mount any volume to the container with -v switch. Without this switch, we cannot mount any volume. And docker volume create is used to create new volumes. Now you must have a question in your mind, where are these volumes created on the host machine? So I will go to cd var lib docker, and you can see the volumes here, and I will go to see what's inside in the volumes, ls-l, and you can see the volumes are actually created in varlib docker. Now I want to remove this volume, so docker volume remove and second volume. So guys, I want to remove all the containers in a single command. How can I do that? Docker ps -a. You can see there are a lot of running containers, and I want to use a single command to remove all these containers. What is that command? It is a dangerous one. Docker rm -f. There are actually two commands combined in a single command. Docker ps -a -q. So this command is actually playing a variable. In order to understand that, the output of this command is passed to the first command. So there are two Docker commands merged together, and now this command will get the container IDs which are running. All right, we will have all the containers IDs, and then those container IDs are passed to this command docker rm-f, and it will remove all the containers in one go. And you can see all the containers have been removed. Docker ps -a, and there should not be any containers, whether it was stopped, paused, or in the exit state. So that is a bit dangerous command, and you must understand it, because this command, it fetches the container IDs, and those container IDs are passed to this command which removes all the container IDs. Similarly, I can use the docker images command to view all images. Now I want to remove all these images using a single command. The command would be docker remove images, okay, -f forcefully, and docker images -a -q. The images are passed, the image IDs are passed to this command, and this command will use the rmi-f forcefully. Now similarly, there are two commands. This command, we will have the image IDs. Let me run separately first of all, so that you can better understand this. Okay, I will run. Now you can see that I have all the images IDs. Now these image IDs are passed to this command, which will remove all the images in one go. So I will run again. Guys, that's why you should practice the commands and remember them. Docker rmi-f, remove the images forcefully. Which images? The images with these IDs. How can I fetch the IDs? Docker images -a -q. Now this variable, let's suppose it's a variable, and it passes the values to this command, and we will have all the images removed. I will hit the enter button. Okay, now we are having our images removed from our system. And guys, now we can see Docker images, and there should not be any image. So the final command would be docker system prune. This command gives us a warning. This will remove all the stopped containers, networks, images, build cache, etc. So I can use this prune command. Never run it on any dev QA or staging or production server. It is just for your learning, for your knowledge. These are really dangerous command, and they remove everything. So if I run docker system prune, every container, every image, cache, networks, volumes are removed. So that was our last command, and this will remove everything on your Docker infrastructure. Hey guys, I hope you're doing great today. Well, this is our chapter number 13, and in which we are going to talk about what is Dockerfile. Guys, I have been waiting for this lecture for so long, and honestly saying that I'm really super excited, because we are going to build custom images with the help of Dockerfile. In our last lectures, we discussed what is Docker, what is Docker used for, and we executed around 50 Docker commands to know what is Docker and how does it work. So I hope that you have you have run all those commands on your VMs, and you are clear with the Docker basics. Now guys, you saw that we have been using the docker pull command, like docker pull ubuntu, for instance, docker pull ubuntu. This is just a revision of the concepts we discussed earlier. This command will pull the Ubuntu image with latest tag from hub.docker.com, which is the official repository of Docker. We pull Docker images from hub.docker.com, right? And I'm sure that you know this concept. And now we know that we have Ubuntu latest image on our VM. We have pulled it. But I want to have the custom images. Now I don't want to use these official images for my application. For instance, I have a Node application, a Java application, or a Go application. Now I will use Dockerfile to build images that are most suitable for my applications. You got my point? In order to build the images of your choice or the images that are most suitable for your applications, you need Dockerfile. Dockerfile is actually a blueprint. You can say it is a blueprint to build custom images for your applications. So let's discuss about Dockerfile in more details. Let's get started. So guys, first of all, you must know that Dockerfile is written as this Docker file. I mean, this is the file. This is Dockerfile with D capital and Dockerfile. It does not have any extension like .js or .php. So there are no such extensions in Dockerfile. It is just Dockerfile with D capital. In addition to that, Dockerfile is written in DSL, domain specific language, and it consists of set of instructions, and those instructions are executed one by one to build an image. And all those instructions run from top to bottom in sequence. Each instruction will run in sequence. So these are a couple of things that you must know for Dockerfile. Now let's learn about the instructions. What are the instructions that are normally used in a Dockerfile? So guys, for this lecture, I will be building and containerizing a Node application. So that Dockerfile would be specific for a Node application. So first instruction of our Dockerfile, which is from with all alphabet as capital. Each instruction is written with full caps lock. So from, and it means that we have to mention our base image here. So the from instruction represents the base image. What is the base image? For instance, I'm using the Node application. I will be deploying the Node application using the Dockerfile. So my base image is node :20 alpine. This is my base image that is suitable for my Node application. So from instruction represents the base image. Now this is the first layer. You are going to build a Docker image from scratch, and this layer is an empty layer, and our image would be built on top of this layer. So guys, there is another concept that you should know, that each instruction is a new separate layer in Docker image. We would be running all these instructions one by one. And guys, I have decided to run each instruction one by one for you so that you understand the purpose of each instruction. And each instruction will build a complete new layer. So this is my base image, and there are Ubuntu, Nginx, Alpine, Redis, WordPress, Elasticsearch. These are all base images that are most frequently used in the Docker file. So for instance, if I am having a Java application, what would be the base images? I can use OpenJDK and JDK 11 or JRE 11. So these would be my base images. And for node application, 16 Alpine, 20 Alpine, 26 Alpine, these are node versions. So that's how we use the from instruction to use the base image in our Docker images. I hope that now this instruction is clear. Now let's move on towards our second instruction. The second instruction is working directory, work dir, work dir, dir. I want to have my source code, my application in home node app. What does this mean? My application source content, code, and other necessities would be copied in this folder. You can have the folder of your choice. For instance, if you want to have the app folder only, you can have it. So I would be using this path where my source code would be copied. Now, the third instruction is run. That is most frequently used instruction, and the purpose of this instruction is to execute commands, to run scripts. For instance, I can use run apt update, and for second line I can use this backslash, and then I can use apt install vim. So that's how we can run different commands, and our image would be built according to these run instructions. So our image would have apt updated, and vim would be already installed in our image. So that is the purpose of run, to run commands, to run simple scripts just like you run on a Linux terminal. And in my node application, I want to create make directory -p, because I have to mention the path home node app, and create this is node modules. I'm going to create a node modules directory where my node modules would be copied when I run npm install command. So this is our third instruction. So our image now has 3 layers, right? First layer from base image, second layer working directory, third layer create a directory in app node modules. Node modules directory would be created in our image. Now I want to copy the content from my local VM, to this app folder. So what would be the command? Copy. This would be the instruction, copy. And for instance, if I am having all my content on this current directory, copy whatever this directory has in node app, home node app. So these 2 dots represents 2 different locations. You have to understand this. The copy instruction will copy what my current directory. For instance, if I am in home DevOps Molvi, this is my VM location, and I have source code in home DevOps Molvi. So copy all the source code in home node app, because this is my working directory. We will practically perform this action and we'll see what does this instruction mean. Again, I'm going to repeat it. This instruction means that copy, for instance, I am in my VM, I am in home DevOps Molvi. This is my VM. Because I'm writing this Docker file on the VM, so my present working directory is DevOps Molvi. So my all the source code is present in home DevOps Molvi. I would use this dot to copy all this content in, this is my image, and home node app. All the content would be copied here because this is my working directory. So this instruction means to copy all the content from my current directory in this working directory. For instance, if I want to copy a single file, for instance, I want to just copy package.json file, package.json, copy. So I can explicitly write the file name as well, package.json, and this dot. So it will copy package.json file, which should be there in our current directory on the VM in home node app. So that's how this copy instruction works. It simply copies everything or the files you mention from your VM into the image. I hope it is now clear. Now our fifth instruction is user, which means that we can set the user of our choice. For instance, I want to have the node user, and our image and files would have all the permissions and ownership of this node user. We can also use W data user, which is also a most frequently used user. So user command sets the user ID and group ID for the files, for the directories, etc. in our image. Since my application is based on node, so I will now run another instruction, execute another instruction, run npm install, npm install. Because I have all the prerequisites, I have created the working directory, I have set the base image and created a node modules directory, copied package.json, and also I have set the user. Now my application is ready to be compiled. npm install actually reads this package.json file and it compiles the modules according to their versions, and run npm install will actually build or compile the code, the source code that we have in home node app directory. So run instruction npm install. This is just like npm run build and npm run install, etc. So these instructions are relevant to node compilation, node package installation. Our seventh instruction would be expose. For instance, I want to expose my application port. I can use the expose instruction, 8080, the port where my application runs on. And the final instruction is cmd command, which means that start the process inside the container or start our application. For instance, our node application is started with node, that is the syntax of cmd, app.js. So that's how this would be the process started in our container. It means that when we build this image and run it into container, our image would be having this process started and our application must be running on port 8080. So guys, this is the Docker file to build and containerize our node application. You can see we have this from base image node 20 Alpine. This would be our base image, and now this our image contains 1 2 3 4 5 6 7 and 8 instructions. It means that there would be 8 layers to build and complete our final version of image. That would be our custom image, and that image would have home node app directory created. That image would be having node modules directory created in our home node app, and it will copy package.json, or we can copy everything in our working directory. The user node will set the node user permissions. Run command will actually compile. It will read this package.json file to compile the node modules, etc. And expose will expose our application port. Normally we don't expose the port, but just for your knowledge, I'm using this expose instruction. The CMD or entry point, these are two instructions that run the process in the container, and the CMD command will run our node application using this app.js file. So we will be having a complete running node application, and there are a couple of other instructions that I will definitely discuss for your knowledge, which are add and URL. For instance, if I want to add anything from internet, I want to add any zip file, I can use this add and this URL. I will use the URL in Dockerfile. This instruction is also commonly used to add anything using the URL. And also entry point. Entry point. It also runs the process in the container, but one of the most frequently asked interview question is that what is the difference between CMD and entry point? Basically, the purpose of both instruction is same, to run the process in the container. But I would say that entry point has a priority. For instance, if the same Docker file has CMD and another instruction entry point, it means that our entry point instruction will run, and we will have our final process as per the entry point, because CMD instruction would be ignored and we will have entry point process running in our container. So entry point always overcomes on CMD instruction. It has a priority. It is for your concept, I would say that entry point has a priority. It is superior on CMD. By the way, the purpose of both instruction is to run the process inside the container, and we can have multiple entry points in our Docker file. The other instruction is maintainer. If you want to mention the name of the person who is maintaining or the email address of maintainer, this instruction is used. It means that who is the author of this image. So I can write my name, or you can write your name or your email address. Similarly, we can use the label instruction, which adds metadata to the image. We can set image names or container names, etc., using the label instruction. So guys, we have completed the most crucial stage of writing the Docker file. You can see that we have written a complete Docker file that we are going to run on our VM. This Docker file will build an image and we will run this image into container. Now let's start our lab. Alright guys, let's start our lab now. Let me log in to my VM, DevOps Molvi. That is my user and I am in love with this user. So I am in CD home DevOps Molvi, clear. You can see that I have created this folder in which we have our node application, CD node app, and I have this application. Now I am going to write a Docker file from scratch so that we can run this application into a container. But before that, obviously we have to create the Docker image for that. Now you can see that I don't have any container running and I don't have any images built before. My VM is clean, so we are going to work from scratch. Now nano docker file. Okay, I am going to create my Docker file. So what was our first instruction? It was from all with caps lock and node 20 alpine. There are older tags. This is a tag and we have 10 alpine, 16 alpine. I was just checking on hub.docker.com and there are multiple tags, so I have chosen this to avoid any compatibility errors. So for instance, let me run this and we will see that we will have one layer, image layer. Docker build command is to build the images and it reads the Docker file. Okay, Docker build -t means tag node image version 1 so that we understand the changes according to our next versions. And dot means that my Docker file is in this directory in node app. So you have to read the Docker file from this directory. That dot means that the Docker file is present in this directory. Now our image will be building now. You can see it and it will take a couple of moments. Okay, so we have the first instruction. You can see that there is only one by one. It means that only one instruction and it just pulled the image, and we must have Docker images and version 1 of node image. What I wanted to show you guys that we are having only one instruction. Now as long as we are going to write more instructions, more image layers are going to be created. Now you can see that it just pulled the image, node image, and we have this tag. Okay, now let's execute our second instruction. So I will be editing Docker nano file, and what was our second instruction? Working directory, work dir home node app. For instance, just for your learning, I'm creating this directory app and app. What would be our image? So it will have this working directory where our content would be copied. This is just for your understanding. For instance, yes, and I am going to run this image. Docker build -t, sorry, I'm going to build it -t node image version 2 dot. Now you can see that there are two instructions, right? Work dir, and this was our from instruction, and now this is our work dir home node app. So our image will now have this path in the container. Now Docker images, we have two versions of images, and I will run this version as docker run -it -d and minus name of the container, my node app, okay, and node image version 2. Okay, now we will have a running container, docker ps. You can see I have this container. Now I will log into this container, docker exec execute minus it. I hope that now you all know these commands. If you don't know these commands, you can check out my Docker 50 Docker commands lecture, and all commands were discussed in detail in 50 Docker commands for DevOps engineers. And Docker exec minus it and container id sh is the shell. Now you can see my default directory where my source code would be copied is this one. I'm sorry, I have messed it, but it was just for your learning. I hope that you will never forget this. So that's how we can specify our working directory. Okay, now let's remove and write the professional one, of course. Nano Dockerfile and home node app. Now this would be our working directory, and yes, I will clear the screen and docker build minus t node image colon version 3 and dot. Okay, our image has been built, docker images, and you can see we have this version 3. Now I will run the container again, so that docker run minus it minus d foreground minus it interactive shell minus name of the container, my second node app, the container name, and the node image version 3. Okay, version 3, because the changes have been done in version 3. And all right, our container is up, docker ps, and you can see that our container is running fine. Docker execute exec minus it container id, or I can use the container name as well. And sh is the shell. Bin bash does not work in this. And tada, you can see that now our working directory is home node app. What did you learn from that? Whenever we log into our container, it brings us to the exact directory, exact folder where our source code would be copied. So now I hope that it is clear what is the purpose of working directory. Work dir instruction clear. So ls minus l, we have this docker file. So guys, now I hope that you're getting my point. We are building the image from scratch from our very first instruction, and we are checking out how can we containerize a node application, and we are learning what does each Dockerfile instruction do. All right, Dockerfile. And now our third instruction would be to create a home node modules directory in home node app. Run, remember, run instruction, and what would it do? It will run this command mkdir, which is to create directory in our image. Mkdir minus p home node app, try to remember it all, home node app node modules. Okay, now our home node modules, this directory will be created in our container. Okay, now we can check control x, yes, and docker build minus t node image colon version 4. It was 4, yes, 4 dot. Now we will have 3 instructions. Let's check out. Okay, now you can see that our third instruction is to create a node modules directory in our working directory. Okay, Now I can log in docker run -it -d and node minus minus name fourth container, and image is node image colon version 4. Now we will check the node modules directory whether it was created or not. Docker ps docker exec minus it, and this is our container id and sh ls minus l. Okay, we have this node modules directory. But guys, what I wanted to show is one of the key point that you can see it is owned by root, and I want to have everything owned by the node user. So instead of root, we must have node user, which should have all the permissions and ownerships on all the source code files and node modules. So we will have to change our docker file a little bit, and nano docker file, I will run another command which is run chown, okay, minus r. That is the same command we run on our Linux VMs. Chown, change ownership node colon node, and I can home node app, and all the files and modules will have the node user and node group ownerships in our container. Okay, now let's check out this instruction as well. Now I will run, you can see docker build -t node image colon v5. That would be our version 5 of this image. Now we will have 4 instruction. You can see the 4th instruction is to give the ownership of node user and group to everything we have in home node app. So I will again docker run -it. Guys, please don't ignore, these are basic steps that you must know. All are basic steps, but we must know what each instruction is doing. Docker run -it minus d minus name fifth container, and image is node image version 5. Okay, clear. Docker ps, now we will log into our this container, docker execute -it and sh. Now you can see our ownerships have been changed. In the previous container, I can log in. This container was having the ownership of root user, which is, we don't need root anywhere. We need the node user to run our node application. So you can see our ownerships have been changed. Now if I log in to docker exec, our 4th container -it, that was our 4th container, and sh ls minus l, you can now see the clear difference, guys. And this is really important to understand why should we change the ownerships, because it can lead to compatibility or runtime errors. So it has the node user and node group, and it was having the root user. So by default, all the files that we copy into an image, and when this image runs, those files or directories are copied as the root user, with the root user. Those files and directories have the root ownerships and permissions, and we can explicitly change them in our docker file. And that was a simple run instruction we have updated in our docker file. You can see non docker file. So we now have 4 instructions, And guys, I can write this run instruction here as well, using the syntax would be uh, for your learning purpose, and I can run this instruction. So that's how we can run multiple commands in a single run instruction. Okay, now I want to copy the content, all content in my home node app. So what was the purpose? Copy. And for instance, if I want to copy a single file, let's check out this instruction: package.json and dot slash, or we can write home node app as well, this full path as well, or dot slash as well. And I will build the image, docker build -t node image column version 6 of this image. And now we should have 5 instructions in our docker image. These are 5 layers, guys. So that's how we can create any image from scratch. You can see now we have 5 instruction, and this instruction is saying that our package.json is being copied in our home node app directory. Now let's this image run into container. We can see we have a lot of images now on our VM. So I will run this image. Docker run -it -d and minus name 6th container, and image is node image version 6. So that's how, guys, I used to repeat all commands. I try to remember all the commands, and you should practice all the commands so that you never forget them. Okay, docker ps, we have this container, and I will run it. Docker exec, I will log in into it, sorry. Docker exec -it and sh in the shell. I can see our package.json file has been copied. So you saw that our package.json file has been copied, and for instance, if we have a package log file, we can use the static so that package.json and package/-log.json file should be copied. And normally in node application there is a package.json file and a package log.json file. So I am copying everything which is package status.json file, and now I will run npm install. Npm install will read this package.json file, which contains the node dependencies, libraries, and other requirements, and it will compile and install. So run npm install, we should have our node application working. Then I will expose 8080. My node application is running on port 8080. You can consult with the developer. It can be any other port as well. So I am exposing 8080 port. So when I run docker ps, I would be able to see the port. It is publicly exposed. We can hide it. If we don't use the expose instruction, we cannot see any port on any container. So the last instruction is the cmd instruction, which runs the process of our node application. Cmd and bracket double quotes node comma and double quotes app.js, because my application file is app.js, and I will run this. So my Docker file is complete, and we have all the necessary instruction. And for instance, if I want to have everything owned by node user, and this is a practice to have everything owned by node user and group, we can also run this instruction. This is just an addition. So copy chown is equal to node colon node dot and dot. So it means that my package JSON file, my modules, and everything that I copy from my current directory to the container will have the node users and node group permissions and ownerships. So that's how, guys, our Docker file is written from scratch. You can see we have all the instruction, and we checked each instruction and what does it do. Run npm install will actually compile the code, and we will have our port 8080 as exposed. We will check while we run the container, and we will hide this port as well, and this is our instruction. Okay, now let's run our docker build command to build this 8th version. Docker build -t node image colon version 8 and dot. Now we will have, okay, we can see the output here. We will have total 7 instructions. You can see that it is going to take some time because npm install is running. Okay, and it has completed. So our image is ready. Docker images. Now we can have, you can see there was a change in the size of the image, because after running npm install there must be node modules, and now we will actually run this into a container. Now our node application has been containerized. We must check how we can run this node application in a container. Docker run -it -d -name my node app, and node version image is 8, version 8. Oh, sorry, it says that there is already my node app final. There was already a container with my node app is running. You can see that, and I have changed the name of the container now. All right, now our application must be running, and I will run docker ps. You can see our port is exposed. You can see, we can see port 8080 has been exposed. Now if I don't use expose in my Docker file, we will not be able to see which port this container is running on. So that's the purpose of expose command or instruction in the Docker file. Now I will run docker exec -it this and sh. All right, let's see what we have in the container. We have everything copied. You can see package JSON log and package.json file. We use directory and node modules, which was empty. Let's see if we have anything in. Oh, that's how we can check. We have everything compiled, and these are node modules. Okay, and now we can see that our Docker file has been also copied, because we copied everything, and it's okay, cat Dockerfile, and it's the same Docker file which was copied from our VM. Now we have to check whether the process is running inside the container. I can use okay. Now it is running, and it is running from the root user, and we can change it using the user instruction. I think I forgot to add this, and clear nano docker file. Okay, I will add user node. Okay, and it is the default. Now we have set this user docker build -t node image version 9, and I will create another version, and you can see that there was no such changes in our instructions. Now our process will run with the node user, not with the root user. So I have already built this image, docker images, and it has been built. Now I will run this image, docker run -it -d, and another addition -p, because I want to access this application on port 8080, which is inside the container. This is the container port, and this is my VM's port. I mean, I want to access the application publicly on my VM using this port. So this is the container port, and this would be my public or external port. You can say this is the internal port and this is the external port, and -- name node app and node image version 9. Okay guys, I hope that now our application is running, and you can see that my port has been exposed, and I can see 8080 as the internal port and 8080 as our external port. And now I can check docker exec -it and sh, okay, and docker ps. Now you can see instead of root user, we have our application running with the node user. So user instruction sets the user ID. Now let us access our application. You can see docker ps, our container is up and running, and Chrome, I will check 192 and colon 8080. Okay guys, our application is running fine. And by the way, I got this application from DigitalOcean's website from their blog, because I love this and use this for the demo. You can see this was built in the Node platform, and I have containerized this application from scratch. We have learned what each instruction does, what is the purpose of each instruction, and how can we containerize any application. So this port 8080 is serving, and we can see our application, node application, is running. For instance, if I want to see the logs, docker logs -f. Okay, you can see that example app listening on port 8080. I have another example of Nginx Dockerfile web app, and you can see I already have a text file created, index.html, and this is just a demo file. Okay, now let's understand what's inside this Nginx Docker file. You can see the base image is Nginx table Alpine, which is very small in size, so I have used this one, and I am copying index.html in this containers location. Port 80 is exposed, and we are running Nginx server in the foreground. So that is a simple Docker file to run any Nginx website, any Nginx web application. So let's run this as well. Docker build -t my web app, and it's gonna take a little bit of time. Okay, and the Docker image has been built. Docker images, you can see it is very small in size, and it is just 12 MB. So I chose a really slim size, and now we will run docker run -it -d -p container port internal, external port VM. Okay, this is the internal container port, and this is the external port where you access the website from your browser, etc. So that is the external port, and minus name of the container, my web application, and web app. Okay, we are running the Nginx application Docker PS. You can see we have this, and port 80 is exposed. Let's see what we have on port 80. 92 and port 80. Okay, DevOps Molvi here. This is my web application running on Nginx. So that was simply a really simple Docker file to run any Nginx application. So you can nano Docker file, you can copy the HTML files, whatever you have in user share Nginx HTML. Now let's see what do we have. Docker PS. In this container, let's log in docker exec -it sh ls -l. We must have content in user share Nginx and ls -l html. So we have the content here, and our okay cat Nginx. So DevOps Molvi here, I have changed it. So the content is running from here, and if I run PS, you can see our Nginx process is running in the foreground, okay, with the root user. We can also change the user from root to www data, just like we did in our node application. So that's how, guys, you can check and containerize any node application. Let me repeat: we have our base image, we have our directory. You saw that we created a custom directory, and that's how the instruction works. And this was the instruction to create node modules directory, and we changed the ownership from root to node. Everything has the ownership of node user and group, and we copied package JSON and package lock JSON file in our home node app. This means that this is the full path, and we can use this short form. We compiled the code, we run our application, we built with npm install. The user node means the process should be owned by the node user. With node user and node group, we copied everything we had in our VM and exposed to expose our port publicly, and CMD means that's how where our process should run. So we can also use entry point instead of CMD. The purpose of both instruction is almost the same. Just like I said, entry point has the priority and it overcomes on CMD instruction. So I hope guys your Dockerfile concepts should be clear. These were some basic Docker files to run, to containerize any node application, and most of the times these instructions are most frequently used in our Docker files. So I hope that your concepts are now stronger, and I would request to please make sure to run all these Docker commands, and I will share the GitHub repo link in the description so that you can have all the content this application and you can run it on your VM. So make sure guys you practice it a lot. More practice the better. Really appreciate if you subscribe my channel. I will see you in my next video, which would be related to multi-stage Docker files. Multi-stage means that we will build a single image with multiple stages using the Docker file. That would be a short lecture, but I thought that you must have the concept of multi-stage Docker builds. So I will see you in the next lecture. Make sure to subscribe my channel. I'm already overwhelmed from your support, from your appreciation. I will see you in the next video. Take care. Bye bye. Hey guys, I hope you're doing great today. This is our chapter number 14, in which we are going to talk about multi-stage builds in Docker. Guys, in our last lecture, we built images using the Docker file. We also learned about different instructions like from, copy, run, CMD, entry point, expose, etc. All these instructions run one by one in sequence to build a Docker image. Now, why do we need multi-stage builds in Docker? And what is multi-stage builds in Docker? We need to understand that first. So, a multi-stage build process allows you to break the steps in building a Docker image into multiple stages. For instance, that Docker file can have multiple stages until we get the final version of the image. So there is also one very important interview question that could be asked in your next interview, that whether we have multiple from instruction or whether we can have multiple base images in a single Docker file. And the answer is yes. We can have multiple base images and we can have multiple from instructions, because those instructions, those stages would be used to get the final image. And there are a couple of benefits of multi-stage builds in Docker. For instance, using this strategy to build images will enable to create the images that only include the required dependencies, and only those dependencies that are required to run the functionality of the image. So we will cut down the size of the images, and also we will reduce the time spent on building the images. So guys, in order to explore it more, let's get started. So first of all, you know that we used a couple of instructions to build a Docker image in Dockerfile. Those instructions can be from, this is our base image, for instance, node colon 20 alpine. Right? Now we ran different instructions like copy, run, expose, and CMD. That was actually our Docker file with the help of which we built and deployed a node application. I hope that you have watched my previous lecture, and if not, that would be a great lecture on Dockerfile. I would recommend that you must watch it. So we get the final image, and its size can be like 500 MB or 400 MB, depends on the base image we are using. And after installing all the packages using npm install, and we get this final image size, which is quite a bit huge. Now that was our Docker file. Okay, now I want to convert it into a multi-stage Docker file. And first of all, you must understand that in multi-stage there would be multiple from instruction. So this first stage will generate an artifact or a binary, and let's suppose I used to say this as build, and we will use this build in our second stage because the artifact or the binaries or the only required dependencies would be compiled into a single runtime artifact, and that artifact would be used in our second stage. So in second stage we will use another from instruction and another base image, but now the stage would be different. That was our as build the first stage. I can say it as final stage. Final. Now, for instance, there are two stages in this Docker file. The first stage will compile the dependencies. It will create an artifact. That artifact or that build, in other words, you can say it as a build. That build will be used again in this step. And what would be the step? Copy. We will copy the build, the artifact from is equal to your first stage. Make sure that both names should match. For instance, I am using here as build. If you are using builder or first stage, make sure that we are writing the same step stage name here. Okay, copy from this stage build, and we can specify the location. That was, for instance, work directory is app. Copy everything from this build into the final image app directory. I hope that you are getting my point. Now this first stage will produce an artifact or a build, and that build will be used again here to produce our final image. And now I will use the cmd command here to run my application, like cmd node app.js, etc. But the beauty of this multi-stage build is that the final version of the image will not be 500 MB or 400 MB. It would be reduced to 200 MB or 150 MB. So we can cut down the size of the images and time spent on building our application with multi-stage Docker builds. So we can say that with multi-stage Docker builds, we get the optimized images that are most suitable for our applications. The other advantages of multi-stage builds are enhanced security, faster builds, and simpler CI/CD pipelines. So let me repeat it again with the help of diagram, and we will proceed towards our lab. And in our lab, we will build both images, a solo image with a single Docker file and another image with multi-stage build. So we can say that this would be our initial step in which our stage 1 will start, and in this stage we will compile all the packages like we will use maven clean install or npm install, compile the packages dependencies, okay, and then we will produce an artifact during runtime artifact or binary or jar, whatever you can say it, you can name it. And then in the next step we will use multistage stage 2, and in this stage that artifact would be used to produce our final version of the image. That would be our final version image, okay, and it will be in reduced size. So that is a general overview of multi-stage builds in which we use the artifact and we divide the Docker file in stages to get the final version of the image. I hope you are now having your concept cleared about multi-stage build. Now we will actually perform in our lab and we will create two separate images and we will compare their size and how multi-stage builds work. That is very interesting thing, and let's proceed towards our lab. Okay guys, I am logged into my VM and I have a directory created with multistage. Since this is our multistage Docker builds demo, and I will go into this directory, you can see that I have two Docker files, multistage Docker file and stage 1 Docker file. Two Docker files, I have created them separately, and don't worry, I will push all of that into the public GitHub repository and I will share the link in the description. Now let's see what we have in stage 1 Docker file. By the way, this is Java Spring Boot application with just a simple text. This is DevOps Molvi here and we will run it. Now nano stage 1 Docker file. So this is just a simple Docker file, just like we discussed in our previous lecture about Node application. This is Spring Boot Java application using Maven wrapper, MVN, Maven, Apache Maven, to compile and build Spring Boot applications. And we will use Maven wrapper here that helps to compile the packages, Maven packages, etc. So you can see that we are using this as our base image. This would be our work directory and we are copying everything in the hidden Maven directory. I have that on my VM in the Docker image, and we will copy the Maven wrapper and pom.xml in the container, and we will give the executable permissions to the Maven wrapper and we will run it to compile all the source code we have, and then all the source code would be copied here in this directory, and then we will run our application. So that is the straightforward Docker file to run any Spring Boot application. Now let me rename it to move stage 1 Docker file to Dockerfile. And now we will try to build our first image, and you can see I don't have any images in my VM, so we will build our first image that is from our this Docker file, which is a solo, does not have any stages. We will build the image docker build minus tag java image and solo, okay, and the other image we will name it as multi. We will tag it. So now we are going to build our image, and it didn't take much time because I have already built, and due to cache it was built quickly. Now I will check Docker images, and you can see that this image is 544 MB, right? The size of the image is 544 MB. Image has been built and compiled. Docker images. I will run it docker run minus it minus d minus p, and I will run it on port 8080. This is our internal port and this is our external port. Okay, and I will name it as minus minus name my Java container and Java image solo. Okay, now our container is running Docker PS. You can see that our container is up and it is running on port 8080. We can also check the logs whether our application was started. Docker logs minus F. And now guys, you can see that our application is running fine. This is actually a Spring Boot Java application. Now I will check whether our application is running on port 8080. So I will just run, let me clear the screen, curl localhost colon 8080. Okay, you can see that it is showing me the text. This is DevOps Molvi here. So it means that our application is running. We can see Docker PS and our container is also running. We can also see the Docker logs minus F and my Java container, and our application is running fine. But we saw that the size of the image is 544 MB. Now I want to reduce this size. So for that purpose, we will use the multi-stage builds in the Docker file. Now we will rename this file, move Docker file to stage 1, so to avoid the conflicts. I have created separate Docker files so that you can better understand the difference between each Docker file. So that was our solo Docker file and this is our multi-stage Docker file. Now sorry, nano ls minus l. Now I will move this, move multi-stage Docker file to Docker file, nano Docker file. Okay guys, now you can see that there are two stages in this Docker file. You got it? Now this is our first stage and this is our second stage. You can see that the stage name is builder. The first stage is named as builder. Just like I told you, you can have the name of your choice, builder or first stage, etc. And now we are compiling the dependencies only. We are now running maven wrapper clean install. It will compile the code and install the dependencies, etc. And then it will create an artifact in this directory, and that artifact or that jar file would be named as some name .jar, and then we will copy from builder. This is one of the critical steps that you must understand. You can see we have two from instruction. This instruction is for the first builder stage and this base image is used as the final stage, okay, as final. And then we are copying the jar file that was created from this stage, and it was created, by the way, this is the path where our jar is located, and I am copying it in this path so that it will run from this exact location. So again, let me repeat it. This is our first instruction, and we are using this as our base image. Okay, this is our base image. As builder means that this is our build stage. Now this is our work directory, and we are repeating all the steps that we did earlier, but there is a slight difference here in which we are just compiling our code. Maven wrapper clean install just reads the pom.xml and compiles the code, install binaries, etc. And then all those binaries are created in the form of a jar file, this dot jar. This dot jar is copied in opt app target, but I don't want to have this jar here, so I will copy the jar file in our path that I have mentioned here. This is our working directory. So copy from builder, it means that copy everything, every jar file or the dependencies, libraries that we got from this builder stage, the first stage, into this location, because we are running our application from this location. Okay, java minus jar is the command, and from entry point we will run our application. So I hope that now you got the difference between a single Docker file and a multi-stage Docker file. You can see there are two from instructions. We are using the same or a little bit different base image. We are having two stages. One is builder stage, the second is our final stage, and this final stage will give us the final version of the image, and we are copying artifact from our builder stage in our this final location from where our application will run. So guys, you can play with this multi-stage Docker file and change the paths, change the location, and have your own locations so that you can get the difference. Now we will run this multi-stage Docker file to get the final version of the image, and we will check whether the final image has the reduced size or not. By the way, we have this image which is 544 MB. Now we are going to build our multi-stage Docker file. The command is same, docker build minus t java image colon tag would be multi, so we can find the difference. Multi-stage, then enter. Our image is now being built. Okay, and it didn't take much time. Docker images. Okay, now you can see that there has been 144 MB of size reduction. We had 544 MB in our solo image, and now we are having 300 MB, so it means that the size has been reduced. Now docker ps, I will kill this container and check whether our multi-stage Docker image works as well or not. Docker rm minus f, and I will kill this container. Docker images, and I will now run another container, docker run minus it minus d minus p 8080 colon 8080 minus minus name second container, and we are now going to use the multi tagged image, java image colon multi. Okay, now our container is running. Docker ps and you can see the command is running from opt app, and our application is running on port 8080. So docker logs -f second container. Okay, our application is running as well, and it has been started. You can see. Now I will check curl localhost. Since we killed our first container, now I will check whether our application is running on this multi-stage Docker image as well, and it is running fine, and we got the same output. This is DevOps Molvi here. So guys, that's how we can reduce the size of the images. You can see the size of the image has been reduced, and you also saw that we have two stages in multi-stage Docker file. It was cached, so it didn't take much time to build. Maybe if you are running it on your computer for the first time, it will take time to compile. I just wanted to save your time. That's why I have been practicing it, and now it was saved in the cache. So you can see there are two from instructions, this and final from instruction, and we used the builder jar in our final stage to get the final image, and you saw that in both ways our container was running and we got the output as this is DevOps Molvi here. And that's it for today's lecture, guys. I hope you liked it, and I will share the GitHub repository link with you guys so that you can pull it and clone it and you can run it on your VMs. It is ready to use, and you don't have to make any big changes. You just need to rename the Docker files. The first Docker file is stage 1 and the second is multi-stage Docker file. So rename, build the images and run them into container and compare their sizes. That was a very interesting thing for me, and I hope that you will enjoy it too. I will see you in our next lecture, which is regarding Docker volumes and Docker networking. Make sure you subscribe to my channel. I will see you in the next video. Thank you so much. Take care. Bye. Hey guys, I hope you're doing great today. Today, we are going to start with our chapter number 14 of our DevOps Roadmap 2024. And today our topic is Docker volumes. Guys, we know that Docker containers are easiest to use with stateless applications because the file systems of Docker containers is ephemeral. What does this mean? If the container is deleted, the data on that container residing on that container would be deleted. So if you're working on a container and you are making some changes on that container, the changes would be lost if you remove the container. Therefore, we need a permanent solution where we can store our data, whether we are removing the containers, stopping the containers, or killing the containers. For instance, if I am running a container and a database is involved in that container and I have to secure and keep my data, so what would be the solution? The solution is to create a Docker volume and attach that Docker volume, or you can mount that Docker volume to that container. After that, when the Docker volume is mounted, remove the container, the data or the volume would be saved, and we can rerun the container or spin up a new container and attach that volume to the container. So in short, the Docker volumes offer persistent storage that is independent of the individual containers. For instance, when we create a Docker volume. Let's suppose we have created this Docker volume. Now I can attach it to a number of containers at the same time. So it means that it is not dependent on a single container. This can be container 1, this can be container 2, or this can be container 3. So the Docker volume is independent. Now let's suppose that one of these containers gets failed. This container is not working, so I will spin up a new container and I can attach that Docker volume to that new container. When we start the containers, we can easily attach the Docker volumes, and we can attach a single Docker volume to multiple containers at one time. So in order to understand more about Docker volumes, let's dive in detail. First of all, we need to understand that Docker volumes are required to store data outside the containers. So it means that whether our containers are failed or lost or crashed, our data would be saved. When we install Docker, this is one of the key points that you must remember. When we install Docker, a dedicated directory is created here, var lib docker, and this directory contains separate folders for volumes, networks, images, etc. So everything we create in Docker, for instance, we create a Docker volume, that Docker volume will be created here. And if we could create a network, it would be saved here. The Docker images are saved here. So var lib docker is one of the key directories to store everything about Docker. Guys, in order to understand the concept of Docker volumes and the importance of Docker volumes, let's discuss one of the key concepts about image layers and container layers. We remember in our Dockerfile section, we discussed about the image layers, right? For instance, we create a new image and we have from run, copy, cmd, expose, Dockerfile instructions, right? A Dockerfile contains all these instructions to build a container from scratch. Now we saw that practically that each instruction creates a new image layer. Now there would be a base instruction from, okay, and these would be all image layers, and source code, for instance, source, and packages, etc., and cmd or entry point. These are all image layers. Each image layer is created when we use the build command to build an image. Okay, these are all image layer. And we know that Docker uses image layers to build an image. For instance, if I have 100 run instruction in a single Docker file, it means that there would be 100 image layers in that image. So when we run this image into the container, a runtime container layer is created. This would be a layer on top of these image layers, and I would say that this is writable and readable, so that we can write and read data on runtime when this container is running. So this is a container layer, and it stores the ephemeral data that lasts when the container is running. When I remove the container, the data would be lost, the data would be gone. So this layer contains ephemeral data or temporary data that is required to run this container, or that container creates when it is running. So when I remove this container, it means that the data on that container is lost. We don't have this data anymore because we don't have the container anymore. Now, for instance, I have a database application and I'm running a database container. I want to keep this data whether my container is stopped, whether my container is removed, or it is crashed, or it is failed. I don't want to lose my data at any cost. What would be the solution? The solution is Docker volume. This would be my Docker volume, and I can attach it to this container. Whether my container is failed, I would have this volume saved in var lib docker directory. Okay, so that volume can be attached to any container. Whether this container was filled, we can spin up a new container and attach that volume to the new container. Now we know the importance of Docker volumes. Docker volumes are used for persistent data storage. And we can create a Docker volume simply with the help of Docker volume create and my volume name. So Docker volume create the volume name and a new volume. For instance, I have the name as volume 1. New volume would be created here in var lib docker volumes folder. We will check it practically. Now I can attach this volume to container 1. For instance, I have this container running and I can attach this volume 1 with the container 1. For instance, if this container is failed or crashed, we don't have to worry about our data. The data would be saved in volume 1 and I will create a new container and I will attach or mount this volume 1 again with my container 2. So that's how volumes can be attached or mounted with a number of containers at one time. And again, let me repeat the concept. Volumes are not dependent of the containers. Whether containers are stopped or working or failed, our volumes would be saved, our data would be saved here in var lib docker volumes folder. And we can attach a single volume to multiple containers at one time. I hope that now you have these Docker volume concepts clear. Docker volumes are used for persistent data storage. When we run a container, the container creates image layers and we have a writable container layer. But when we run a container without a volume, if this container gets removed, the data would be lost. So for permanent data storage, we have Docker volumes. We can create Docker volume with Docker volume create command, and we can mount, we can attach this Docker volume to any container for persistent data storage. And one more thing, that if our data is updated, it is automatically updated inside the container as well. And if there are any changes made with the data inside the container, that changes would automatically replicated here on our volumes directory on our host machine. If we make any changes inside the container regarding this volume, all those changes would automatically replicated here in var lib docker. We can the data, it means that the data is synced. When we mount any volume with the container, if there are any changes happening inside that container, those changes are updated automatically. So when we create a volume, a new folder would be created here. Okay, and if any changes are happening inside the container, all those changes are replicated here as well. In addition to that, for persistent data storage, we have another option which is known as bind mounts. Bind mount. So we have two options, volumes and bind mounts to store our data, but the preferred mechanism is to use Docker volumes. Now let's discuss the difference between Docker volumes and bind mounts real quick. So we can create Docker volumes separately and attach them to any container. Whereas in bind mounts, we can mount a folder. It is a folder which is on my host machine. This is my host, and this folder is directly mounted on my container. So what is the key difference between a volume and a bind mount? Volumes are completely managed by Docker. And when we create a volume, a separate folder is created in varlib Docker. And it is not dependent on the operating system of the host. It has nothing to do with the operating system of the host. Volumes are independent. Whereas in bind mounts, the bind mounts are dependent on the directory structure and the underlying operating system. So since volumes are completely managed by Docker itself, that is why we prefer to use volumes instead of bind mounts. And you must remember and you must know that in bind mount, a folder or a directory on the host machine, this is my host machine, that folder is directly mounted inside the container. We will, of course, see it in our lab, how we can mount a folder and how can we create a volume and attach to the container. There would be a complete lab session. So now let's discuss a couple of Docker volume features. First of all, we know that the Docker volumes are used for persistent data storage. That is one of the key advantages or benefits or features of Docker volumes. We can easily back up and migrate Docker volumes among different Docker hosts. So the backing up and migration in Docker host is easy while we use the Docker volume. Docker volumes work both on Linux and Windows machines. This is also one of the key features of Docker volumes. They work smoothly both on Linux and Windows. And like we discussed before, we can attach a single Docker volume to multiple containers at one time, or multiple volumes can be attached to a single container at one time. So it means that Docker volumes can be shared safely among different containers, Also, we can store volumes on remote hosts and cloud providers. It means that with the help of Docker volumes, we can store them on remote hosts, other servers, and cloud providers. And also we can encrypt our volumes. So guys, these are a couple of major Docker volume features in which we can store our data persistently. We can backup and migrate our Docker volumes among different Docker hosts. We can run Docker volumes both on Linux and Windows machines, and we can create multiple Docker volumes and attach multiple Docker volumes to a single container, or a single volume can be attached to multiple containers safely. We can store Docker volumes among different and remote hosts and cloud providers, and we can also encrypt our Docker volumes. So I hope that your Docker volume concepts are now clear. Now let's jump in and start doing the lab. Alright guys, now let's start our lab. You can see I am logged in my VM. First of all, we need to understand about this critical folder we have, directory of Docker. It contains everything about Docker. When we install Docker on our VM, it is created by default. And for instance, we create volumes. The volumes are created here. We create images. We have images here like containers and plugins, drivers, etc. Everything that we create using Docker commands is created here. We will create bind mounts and we will create Docker volumes, and we will see practically that those volumes reside here. That is why it is persistent storage. Everything that we create using the Docker volume create command, volumes are created here in cd volumes directory. Now these are just the default metadata database. Now for instance, I create a new folder. Let's start from the beginning. Make directory and testing mount. We will test bind mounts first. Okay, bind mounts. Now this directory has been created, and we will mount this directory inside the container. We have docker ps -a. You can see we don't have any container running. Docker images, we have just one nginx image, and we have this testing mount directory, and I want to mount it inside the container. I will not create a Docker volume. We are going to first see how does the bind mounts work, because bind mounts are straightforward. You just mount any folder. For instance, I have node app, I have this multistage folder, I have this folder. We can mount any folder from our host inside the container. So that's why we are dependent of our underlying operating system, and volumes are independent. We can create volumes and we can attach them anywhere from anywhere. Now this directory would be mounted inside the container. And how bind mounts work, let's spin up our container. And first of all, you can see docker volume ls. We don't have any volumes created as well, or any bind mounts. If we run the same command, it will show us the bind mounts as well, docker volume ls. Now let's spin up our first container. Docker run -it -d-p, it is nginx. And I hope that you have practiced the Docker commands and you remember them. So -v, the v option is used for mounting and creating bind mounts. -v. Now I have to give the full path of my this volume, this directory, home, DevOps, Molvi, and testing mount. And this is actually my source, right? This is the path I am using from my VM. This is my source, and this is my target, which directory I need to mount on. And I am using opt. For instance, everything that I mount should be there inside the container's opt directory, and minus name of the container, container1, and the image, okay, nginx latest. So that is the command, guys. You can see docker run a container, interactive session, foreground, -p, port, container, outside port 8080. -v is the option to create the bind mounts. We will also check the hyphen hyphen dash dash mount option as well. So minus v is a bit simple, and minus v is used to mount. This is my source directory and this is my target directory. This is my host or VM. That is why bind mounts are dependent on the host. We have to give the full path. And this is my containers directory and containers name and the image name. All right, our container is up. Docker ps. So we have our container running. Okay, now I will log into container docker exec -it and sh. You can see we have this volume created. Now testing mount was empty, guys. There was nothing inside the container, sorry, the folder. So guys, you can see that my testing mount folder was empty. Now I am inside the container, and in opt, because we mounted the opt directory inside the container, and our source directory was home DevOps Molvi and testing mount as per the command. Now I will create a test direct file here, abc.txt. That file should be created on my host as well, ls-l. You can see this is created here in testing mount, because now the bind mount is working perfectly, and we have mounted this source inside the containers opt directory. Now let's create a file here and see whether the changes are replicated inside the container as well. This is interesting, by the way. Touch error.log. I want to create a log file, and I want to see whether I have this file inside my container. And yes, we have this file created inside the container. So guys, this is persistent storage, and all the changes are, inside the container, what is happening inside the container is being saved, and we should not worry about our data loss. So that's how bind mounts work. And we can create, should I create another one quickly? Okay, let's suppose I am creating another bind mount, and in which I will mount this directory. This is my node app, and we worked on our node application, if you remember, in our Dockerfile section, and there is a lot of content here about our node application. I will mount the whole folder, whole node app directory inside the container. Okay, now what would be the command? cd docker run -it -d -p. I will run it on any other port to avoid the conflict. -v home DevOps Molvi. Now I have to give the complete path of my source folder, node app, and full. This is my you can say this is my target directory in the container, -- name container 2 nginx latest is the image. Now our container is running. I can see 2 containers here, and this is our second container. Now I will log in docker exec -it to check our bind mount. We are mounting our source folder inside the containers directly. These are bind mounts. That's how bind mounts work. sh cd home, and we should have all that data inside the container. So guys, I hope that you are now have a clear picture of how the bind mounts work. And now, for instance, if this is the file, uh, docker file, cat docker file, sorry, cat, I have to write it completely. Now I am making some changes from my bind mount. Now I would be creating some changes, and we will compare whether we can replicate those changes here. Clear cd home DevOps Molvi node app nano docker file. For instance, if I am changing anything, this is my change in the file to check bind mount. I've done this a little change in the docker file, and now let's see what's happening inside the container, whether we are replicating this change. Cat docker file, oh sorry, clear cat docker file. Okay, you can see we can see the changes we are creating in the files. So that's how our persistent storage work, guys, and that was actually the bind mounts. Now we are going to see how the Docker volumes work. So I hope you have everything cleared about bind mounts. Now let's create our first volume. I will remove these containers to avoid any mess. Docker rm -f, and both containers can be removed with this single command, docker ps -a -q, and my containers have been removed. Now guys, I will create a new volume. Volumes are independent, volumes are fast, and volumes can be migrated securely, volumes can be encrypted. We can create remote volumes on remote host or on our cloud providers. These are the benefits that we cannot get in bind mounts. That's why Docker volumes are always preferred, and Docker volume ls is the command to see whether we have any volumes created, and the answer is no. We don't have any volumes created. Docker volume create my first volume. Okay, now the volume is created, docker volume ls, you can see it, and the default driver is local. Okay, the default driver is local. And now if I want to inspect and see more details about this docker volume inspect my first volume. Sorry, you can see it was created at this time and its driver is local. This is the mount point. Now let us see the mount point, and it is here, cd var lib docker volumes. Guys, this is one of the key directories of Docker, and it can be asked in your interviews that which directory contains everything about Docker. So it's var lib docker and volumes. We should see our first volume. My first volume is created here, and this is the sorry, okay, my bad. And this underscore data is the default mount point for this volume. Now everything we create inside the container and using this volume would be permanently stored here in this mount point. As per our inspection, we saw this is our mount point. Now let's create a new container, and we will attach this volume to that container. Okay, and we will use the mount hyphen dash dash or hyphen hyphen mount option here in this command. The command would be slightly different. Docker run minus it minus d minus p, okay, at colon at. Now minus minus or hyphen hyphen mount, okay. Now this is our command in which we are going to mount our volumes from our source directory. Now using this option we are going to mount our volume, my first volume that we have just created, inside the target directory of the container. So we will have the source and target here as well. Mount now we will have to specify the source and target. So the source is equal to source, okay, source is equal to the volume name, my first volume, and target is equal to, for instance, I am using this target again. We will use the home or any other directory as well. We can target any directory like the logs directory in Nginx as well. So that's how the syntax of this command. Now minus minus name of the container, container1, and Nginx latest is the image name. So guys, let me repeat this command again. Docker run interactive foreground minus port inside outside and minus minus mount. You have to focus on this especially. So this is the volume which is our source volume, my first volume, and this is my target. This first volume, source volume, would be mounted here, and this is our container. Let's see. Okay, our container is up and running. Docker ps. Now docker exec minus it container id sh. So our mount point is opt, okay. Now something happening inside the container. For instance, we have a log file here, touch error.log, and this file is continuously updated, okay. Now this file is created and we should have this file here as well inside our mount file. You can see we have this error log file inside our mounting. So that's how it is secure way to store your data, and our data would be stored. Now I can create any directory here inside the container as well. Make dir my storage, and this directory should be created here as well inside our mount point. You can see. So this is the volume. Now let us inspect the volume again. Exit docker inspect my first volume, okay. We can inspect, and we can also inspect docker inspect container1 pipe symbol grab volume. You can see this is the type of the volume and source, and this is the mount point. The container is also showing our the information about our volume. So guys, we should we should remember how this command works. This is really important. This is the mount option to mount any folder, any volume. You can see we don't have to give any source path. We are not giving any source path. We are just giving the name of our volume, and it is mounted inside our containers opt directory. Now let's create another container so that we can revise this command. Docker container run minus it minus d minus p 81 colon 81 minus minus mount. Okay guys, the commands should be practiced a lot. Again, I say it in every lecture so that you do not forget those commands. Now source is equal to, okay, my first volume. I will attach this volume to another container so that the second concept of attaching single volume to multiple containers is clear. And target is equal to slash home minus minus name container 2 nginx colon latest. We have this container running and we are attaching our first volume inside the container 2's home directory. Now docker ps, and we have this container docker exec minus it sh cd home. Now guys, you can see that whatever the content of my first volume we had in this is attached to the second container, and we have this inside the home directory. So that's how we can change the mount points. We can attach one volume to multiple containers. You saw we attached this first volume, only one volume, to two containers, and similarly we can create multiple containers and attach this single volume to multiple containers at one time. So that's how the volumes work. And now if I inspect docker inspect container 2 and grab volume, you can see we have the same, my first volume attached to this, and we have the same mount point for this volume. Now there is one interesting thing that I want to show you guys. For instance, docker exec, I'm going to create a change inside container 2 container, and we will see whether we have this change inside container 1 sh. Now the mount point is cd home of this container, touch new change .php. So make sure that you are making changes to the correct mount point. And now I have changed this in home, and let's see if we have this change in here. Okay, we have it in our mount point. You can see the file has been created. Now let's log in to the container 1 and see whether we have this change over there as well. Docker ps, this is my container 1, docker exec minus it container 1 sh, and docker exec minus it, oh sorry, the command is incorrect. I got worried what's happening. So now the mount point is opt. Okay, you have to remember this. Now we can see the change here as well. So single volume mounted on two containers, and we saw if the change is happening on one container, it is replicated across the mount point and other containers as well. So that was really interesting to see how the volumes work in Docker. So we can remove our volumes, docker volume ls, and for instance, if I am removing the container and there would be no impact on our volume, docker ps, and I'm removing this container, docker rm. I have removed this container, and you can see our volume is still there, docker volume ls, but we cannot remove a volume if it is attached to any running container. Now let me remove this volume, docker, since it is still attached to the container 2. we have this container running, Docker PS. You can see we have container 2 running. Now I want to remove this volume, and it will not allow me to remove because it is attached to a running container. Let's see this. Docker volume remove rm, my first volume, and it is saying that the volume is in use. So until and unless we remove this container, then we would be able to remove the volume. Docker rm minus f, and now I will remove the container 2. Now we are able to remove the volume because it is not attached to any running containers. So that's how, guys, the volumes work. And we must know the difference between bind mounts. We have also checked how bind mounts work, but you saw that the Docker volumes are more resilient, and we can create volumes according to our choice. We can create multiple volumes, and we can create a single volume and attach it to multiple containers. So the following command is showing how we can create a mount point using the -v option to attach any volume. Docker run -it -d -p and container port 8080 -mount. Okay, and this is our source is equal to the volume name, and comma, this is our target is equal to any directory or mount point inside the container, like opt, or in case of logs, user share nginx logs directory. Okay, if I want to mount any log volume inside this container, and minus name of the container 1 and nginx latest. Now this would be our source, and this would be our target. If I do not create any volumes, it will automatically create a new volume. I didn't create any source volume, you can see, and it has created a volume with volume name, Docker volume ls. So that if we do not create any volumes explicitly before, we can create on runtime using the docker run command. So these were the commands to create volumes. You saw how can we create volumes and how we can attach a single volume to multiple containers. Also, you saw that how we can remove a volume, but we cannot remove any volume if it is attached to a running container. So that was really interesting for me, guys. I hope that you will also practice these commands, and you will find really interesting. Please make sure to subscribe my channel, and if you have any kind of suggestions for me, please write in the comments. I will definitely read all your comments. I will see you in our next lecture, where we will discuss about 50 Docker interview questions, and also we will discuss about the Docker networking. That is also something very exciting coming in, and then we will move towards our Docker Compose lectures. I really need your support. Make sure to subscribe my channel, and if you have any questions, please ask me in the comment section. Take care. Bye. Hey guys, I hope you're doing great today. This is our chapter number 16, in which we are going to talk about Docker networking. Guys, we know that networking is a process in which we transport or exchange data among nodes or servers. We also know that networking is a process in which we connect two or more computers or servers or VMs to enable the transmission of information and resources. When VMs or servers are connected via a network, they can easily exchange the data and they can also easily communicate with each other. So in your graduation, I am sure that you have studied about star topology or ring topology and those mechanisms to communicate, to bring different computers, different servers on a single network. Like for instance, we have this router, and this router is used to connect different computers, different servers together so that they can communicate with each other. This is a router, okay? And now via this router I have connected different computers together, and now they can communicate and talk to each other without any issues. Now there should be a question in your mind that how Docker containers communicate with each other. Guys, networking in containers is almost the same thing in which Docker containers can communicate with each other or with the external workloads. By the way, containers have networking enabled by default and they can make outgoing connections. A container has no information about the network it is attached to, or a container does not care about its peers whether they are using Docker networking or not. A container only sees or watches a network interface with an IP address, a gateway, a routing table, DNS services, and other details. We will see in the lab session that when containers using a single network, they can communicate with each other easily. But before that, we must know what are the types of networking in Docker. So let's get started. Okay guys, now let's talk about the networking types or drivers. We can say them drivers. Some people say as networking types, and some say that these are networking drivers that are used by the Docker containers. But this is one of the most important concepts, that when we have a network created, for instance, this is Docker network bridge is the driver, then if all these containers are attached to this network, then these containers can talk to each other. I can ping this container from this container, and I can ping or access this container from this container, because they are all using the same bridge network or bridge driver as their default network. So we can say that this Docker network configures the communication between these neighboring containers. And if we want to connect these containers and we want to transfer data among these containers, we must have to connect these containers to a network, to a single dedicated network. We will see in our practical lab that when we connect multiple containers to a single network that we will create ourselves, then we can easily ping these containers from any container. I mean, this is for instance container 1, this is 2, and this is 3. 1, 2, 3. So this container can be pinged or accessed from this container 2, and container 2 can be easily pinged or accessed from container 3. Alright guys, the first networking type or driver you can say is bridge. The Docker official blog says that these are all networking drivers like bridge, overlay, host, null, none, etc. But other technical blogs say that these are networking types. So in order to understand, just assume that these are networking types in Docker. For instance, bridge, host, null, none, and each networking type has a different function or speciality. So the first type is network bridge. The bridge network creates a software bridge between your host and your container. For instance, this is our host, and this is our container, and these are connected with each other via a bridge network driver or networking type. Now the containers connected with the bridge network can communicate with each other. They can talk to each other. And one of the most important thing that they have nothing to do with the outside network. Using bridge network, they can communicate with each other. And using the bridge network, each container has its own IP address. For instance, we have container 1, this has an IP address, and we have container 2, this would have another IP address and connected to the bridge network. And similarly for container 3 and 4, we will have all these containers will have their separate IP address. Guys, there are only few points that you must know regarding the bridge network driver. It is the default driver. For instance, if I create containers and I do not mention a specific network, the containers would be created on this default bridge network, and each container will get a separate IP address. I hope now you are cleared about the bridge driver. Now, the second driver is, or second network type is host. In this type of networking, or this is the type of networking driver in which the containers will not have any IP addresses, and the containers will be directly created in the system network. And definitely it will remove the isolation between your host or server and the containers. It means that if we want our containers to use the host network, we can use this driver, and the containers will use the host network or the VMs or the servers network. The containers will not get the IP addresses like in bridge network, in which containers get their own IP addresses. In host driver, the containers will not get the IP addresses. Instead, the port binds will be published directly on the host machine. Just like, for instance, 192.168.1.22:80. Now this is the host IP. This is my host and this is my port. And in host driver, this port would be directly bind to the IP address of the host. Okay guys, the third type is overlay. Now this is a little advanced type of networking, and it involves two or more than two separate Docker hosts or Docker daemons. For instance, I am having 3 or 4 Docker servers or Docker hosts where Docker engine is running, and I want to communicate these 4 hosts together. I will use the overlay networking driver or networking type. So I can say that overlay networking is a distributed type of networking which spans over multiple Docker hosts. And using the overlay networking driver, those Docker hosts can communicate with each other. And guys, by the way, this type of networking is used in Docker Swarm clusters, that which would be a little advanced type of stuff. These clusters can have multiple Docker hosts or multiple daemons, Docker daemons, and in order to have these Docker hosts and Docker daemons connected with each other, the type of networking which is used is overlay networking. Okay guys, the fourth type of networking driver is IPv4. In this type of networking, you will have the control over the IPv4 and IPv6 IP addresses assigned to the containers. And similarly, the fifth driver, which is MAC-VLAN, as the name says, in this driver, we will have the full authority or the full power to assign MAC addresses to the containers. Just like we have the full power to assign IPv4 addresses or IPv6 addresses to the containers using these drivers. Using MAC-VLAN driver, we can assign virtual MAC addresses to the containers. The sixth networking type or networking driver is none, and it means nothing. Using these drivers, the IP addresses won't be assigned to the containers. And using this networking type, the containers cannot communicate with each other, and we cannot access any container from any other container. Now let's discuss the types of networking using this single diagram. This would be the networking type or networking driver like bridge, host, overlay, and this is my host. So first is bridge. This is bridge, B-R-I-D-G, bridge. In bridge networking, we can have multiple containers, container 1, container 2, container 3, container 4. So this is my host, and using this bridge network, all these containers can talk to each other via this networking driver. This is my networking driver, this is my host, and I am using this networking type in which multiple containers can talk to each other. Just let's assume that this is their mode of communication and they are communicating with each other, they are talking to each other. Networking, the container 2 can talk to 3, 3 can talk to 4, and 4 can talk to 1, and they can be easily accessed using the bridge networking. Okay, and one more thing, 192.168.11.12.13. So each container will get a separate IP address, and there would be a gateway 1.1, 192.168.1.1, and using bridge networking we will have each container its own IP address, and they can communicate with each other, they can talk to each other using the bridge networking driver. Now let's talk about the host. This is, for instance, the second type is host, in which the container will use the network of the host. And for instance, if this container, this is my container 1, this would be using the port of the operating system. Okay, and now it means that this IP address of the host and the port is bind to the container 1. Now it cannot be used by any other container because the port 80 is bind with container 1. So similarly 443, if I have another port, this would be bind towards the container 2. Okay, and the IP address would be the same of the host. This would be my host IP address 168.5.5. For instance, this is the IP address of the host, this is 5.5, and this port cannot be used by this container, and 443 cannot be used by container 1 because they are using the host network in using the host driver. Now the third type is overlay. In overlay we can have multiple hosts like that. This is, for instance, my host 1. This is my host 1, and this is my another host 2, and this is my another host 3. All are running Docker engine. This is my separate Docker engine. This is my separate server running Docker engine. And if I want to communicate these 3 hosts together, we will use the overlay networking. So the host running Docker engine separately can communicate with each other. So the networking type would be used is overlay, in which multiple Docker hosts can talk to each other. Okay guys, the other type is IP VLAN, and using this networking driver, for instance, this is my container 1, this is my container 2. I can assign IPv4 and IPv6 addresses to these containers. of my choice. And similarly, using the Mac VLAN, this is Mac VLAN. Using this driver, I can assign the MAC addresses to these containers. This container will have the different MAC address, this container will have the different MAC address, and that's how Mac VLAN and IP VLAN drivers work, in which we have the authority to assign IPv4 and IPv6 addresses in IP VLAN and MAC addresses using the Mac VLAN networking types or networking drivers. The last type is none, which is the networking type in which the containers will have no connectivity with the outside world. They cannot talk to each other as well. Container 1 cannot talk to each other. Container 1 cannot talk to container 2 and vice versa. The containers will be isolated and they will not be on any network. For instance, this is my host and this is my container. And this container 1 would not be able to talk or communicate with this container 2. And container 2 cannot talk to container 1 if we are using the non-network drivers. Guys, let me repeat the networking types or networking drivers we use in the Docker networking: bridge, which is the default driver, and the containers, when we do not mention the networking type, are created by default on the bridge networking. In bridge networking, all the containers get the IP addresses. Each container will have its own IP address. In host network, the containers will not have the IP addresses and they will use the host network, the VMs or the servers network to connect. And it means that there will be no isolation between the Docker containers and the host. The third type is overlay, which is used for Docker Swarm clusters, and when we have multiple Docker hosts and we want those Docker hosts to be on the same network, we can use the overlay type of networking. The fourth type is IP VLAN, and using this type of networking driver, we can assign IPv4 and IPv6 addresses to the containers. And similarly, in Mac VLAN, we can assign MAC addresses to the container, and we will use the none type of networking if we do not want our containers to communicate with each other. This type of networking would be used. Okay guys, now let's run some networking commands in our lab session so that we can know how the Docker networking works in Docker. Okay guys, now let's start our lab. First, we want to know which networks we have on our VM. So the command would be docker network ls, and it will show us all the networks that are created on this VM using the Docker. So we have the default bridge network, we have a host network, and a network which is none. So if we want to connect, these are predefined networks. We cannot remove them. When we install Docker, the Docker engine creates these pre-default networks. For instance, if I want to remove any network, Docker network rm remove -force. Let's see if I want to forcefully remove this network. It says that bridge is a predefined network and cannot be removed. You cannot remove these networks. For instance, if I want to forcefully, you can see how I am trying to remove these networks forcefully, but still I am not able to remove these networks like host. This is also a predefined network, and similarly the last none network is also a predefined network, Docker network rm-f, and we cannot remove these networks because these are predefined and these are configured when we install Docker. In order to create our own network, the command would be Docker network create and the name of your network, my network. Now this network that we are going to create, it will use the default bridge network driver. Now I am going to create this network in front of you, and the default driver would be the bridge, or default networking type would be bridge. Now Docker network ls, we can see my network and the driver or the networking type is bridge. Okay, now for instance, Docker ps, I don't have any containers. Docker images, I don't sorry, I have two images, busybox and nginx. Let's use the busybox Docker image to run two containers, and we are going to communicate with these containers. Docker run minus itd minus minus name container one and the image name busybox. Okay, now I am just using this command to create a container. Similarly, I am using the second command to run container 2. Now I have two running containers. For instance, if I log into this container, docker exec minus it, now I try to ping container 2, and it will not respond to any ping request. Because what's the issue? Because they both containers are not connected to any network. Okay, now you can see it is saying that bad address container 2. And similarly, if I log in container 2 and I will try to access container 1, it will ping container 1, and we will not be able to access or ping container 1 from container 2 and container 2 from container 1. What's the reason? Because both containers are not on the same network. Okay, now I will connect them to a single network that I have just created. Docker connect Docker network connect and I will connect container 1 with my network. Now I can inspect this container and see whether it is connected with my network. Docker inspect pipe symbol grep minus I network. Okay, you can see that it is connected with my network that I just created. Now I will Docker network connect is the command to connect your containers to any network. My network, the network name and container ID or container name. Now I will inspect container 2. You can see both are now on the same network. Now I will log in to container 1. Okay, now I am inside container 1 and I will try to ping container 2. You can see that we are now able to ping container 1 from container 2, and similarly now let me log in to container 2. Docker exec minus it container 2 sh. Now I'm inside container 2 and I will ping container 1. You can see that now both containers can communicate with each other. Now they can be pinged from each other. Docker network ls, it shows us the type, it shows us the current network created. We can see there are four types of networks. This one was created by ourselves. We created this network. Now I will remove these containers and I will repeat this exercise once more. Docker rm -f and docker ps -a -q, and I will remove those containers again, and I will run docker run -itd -name container 1 -network. That's how we can run any container, by attaching this container to a network, my network, and the image name busybox. Okay, now similarly we can run the second command, docker run -itd interactive and detached -name container 2 network my network busy box and the image. Now I should have two containers, and if I want to inspect each container, I can see docker inspect and pipe symbol grep -i network. You can see these containers are attached to my network. Now let me run another container, and I will not attach it to my network, the network that I just created. Docker run -itd, okay, -name container 3 busy box. Okay, now let's see, just I told you before that every container that we create connects to the default bridge driver. Okay, now docker ps, we should have 3 containers. Now this is the container 3, and if I inspect this container, docker inspect pipe symbol grep -i case insensitive -i and network. Okay, you can see that this the network mode is bridge, and this is the network ID. Now docker network ls, now you can see that it is attached to this bridge network, okay, the default network. And just we discussed that every container that we create, they attach or they use the bridge network, which is the default network. And you can see that it is attached edf, this bridge network, this container was attached to the bridge network. Container 1 and container 2 are on the same network. We saw that they can communicate with each other. For instance, if I log in docker exec -it container 2 sh, and I can ping container 1, because they are all both are on the same network. But since container 3 is using the default network, it is not on our my network, we cannot communicate with container 3 from container 1 or 2. Container 3. Now you can see that this container was not connected with our network. That is why we cannot communicate with this container. In order to bring this container, we can use the docker network connect. We can change the networking driver, by the way. Docker network connect my network, type of networking or your network name, and container 3. Now container 3 is also using the my network. We can ping container 3 as well now. Okay, so you can see when the containers are on the same network, they can talk to each other, they can communicate with each other. And we also saw that by default, if we create any container, it connects with the bridge network. Okay, now we can see Docker network ls, and in order to remove this network, Docker network remove my network, it says that we cannot remove this network because it is being used by 3 containers. Okay, so we can use Docker network disconnect and my network container 1. Okay, and similarly container 2 and container 3. All 3 containers have been disconnected from my network. Now we can use the network Docker network rm command to remove my network because it is not being used by any of the containers. Docker network ls, and you can see that our network has been removed. And now guys, I will create a new network where I will define the subnet mask and the IP range for the containers. And then we will check what kind of IP addresses our containers are getting. So let's dive in. Docker network create driver. We can specify the driver, which is bridge subnet. This is my subnet and this is my IP range. Okay, and I would have the same subnet and same IP range. And new network, and the name of the network is new network. Okay, we have created this new network with the subnet and IP range. Now let's inspect this, and our network is new network. Okay, now you can see that the subnet is, we defined the subnet 10.0.42.0 and the IP range. Okay, now the containers that we will create will have this IP range. Okay, and let's check the gateway. Okay, Docker inspect new network pipe symbol grep -i gateway, and it should be okay. When we will create the containers, we will get this gateway as 10.0.42.1. that would be the default gateway. Okay, now Docker run -itd -name container 1 and -network new network. Okay, and the image name busybox. Okay, now let us create another 2 or 3 containers. This is container 2 and this is my container 3. I will be using the same command to create multiple containers. Okay, so that we can see what IP range are we getting. Clear. Now let's inspect Docker container 1. Docker inspect container 1 pipe symbol grep -i network. Okay, now we can see that it is attached to the new network. Right, now let's see what IP address this container has. Address, and you can see the IP address is 42.2. Okay, the first 42.1 has been reserved for the gateway. Let's confirm the gateway as well. Gateway. Okay, you can see the gateway for this container is 42.1, and it would be the same gateway for all the other containers. For instance, if I check the gateway for container 2, and it is 42.1, for container 3 it is 42.1, and similarly for container 4, 5, 6, 7 and 100, the gateway would be 42.1. Now we saw the IP address of this container is 42.2. Okay, Docker inspect container 2 should have 42.3 IP address as per the range, and pipe symbol grab address, minus I, it makes insensitive. Now you can see this I minus I switch makes it insensitive, case insensitive. Otherwise I have to use this as a whole without minus I. So you can see it is 42.3. Now for container 3 it should be 42.4, and for container 4 it should be 42.5. That's how we can create containers and attach them to a specific IP range. Okay, and that's how we can create a network with a subnet mask and an IP range. And you saw that we connected multiple containers, we created multiple containers, and then we connected, and we saw their gateway and their IP address. Now we can, these containers can communicate with each other as well. Let's suppose docker exec minus it and container 1, okay, sh. Now I will ping container 4, and guess what, we are getting this IP address. And now for instance, if I log in docker exec minus it and container 3, okay, and sh is the shell, ping container 4, and we are getting the same IP address of container 4. Similarly, ping container 2, and that's how, guys, you can see we created this. Let's revise the command. Okay, docker, let me clear the screen. Docker network create and the driver minus d, okay, bridge. If you do not specify the driver, the default driver would be bridge as well. Okay, that's something I told you in the start of the video, that bridge is the default network driver. And subnet. Okay, now we need to specify the subnet here. Let me change the subnet here from 42 to 50. Okay, that would be subnet and minus IP hyphen range. Okay, that is the same range, and minus network name of the network is dev network. It is saying that there is no yes, I just need to mention the name only. And okay, the name works for the containers. So now docker network ls, and you can see we have this dev network and its driver is bridge. Now if I inspect this dev network, docker inspect, guys, this inspect command is one of the fantastic commands that I love the most, because we can use this command to troubleshoot any problem with anything running on Docker, whether it is an image or a container or a volume or a network, we can inspect, we can troubleshoot using this inspect command. So now we can see all the details of this, and you can see our subnet is now 50.0 and our IP range is 50.0. Now the gateway would be 50.1, and from that our containers start getting IP addresses. So that's how we can specify the subnet and the range for our containers. Okay guys, if I want to bind the port of the container on the host machine's IP address, the command would be docker run -itd my application to run on port 80 on the host machine, and this is the internal port, the containers port, and minus minus name web1, let's suppose, and nginx. Now we can see the container is now bound on port 80, but the IP address being used is the host IP address. This is the host IP address, and my container is bind on its port 80. Now if I want to create another container, whether I want to change its name web2, but you will see that this port has already been occupied. Okay, you can see this port is already allocated, and if I run localhost and colon 80, you can see, sorry, curl localhost, and we can see welcome to nginx and the default output of the our nginx web server. Similarly, if I run localhost colon 80, we should not get anything like that, and we can bind localhost as well using the same command, docker run -itd -p and 127.0.0.1, and this is my host. Okay, my application should run on localhost port 80, and the containers port, nginx is running on port 80 inside the container, you must understand it, and minus minus name web2 and nginx. Okay, it is saying that web2 is already in use, and I will create another web3. There is another container running on web3. Now if I run curl 127.0.0.1 and colon 80, we should get this output. And similarly, if I run this IP address, the host IP address, I'm getting the same output. So that's how guys we can bind the host port with the IP address and map it on the containers port. Now you can see that we mapped the host port with IP address, we bind it. Now this IP address was bound with port 80, and it has been mapped inside the containers port 80. Okay guys, the last command of our today's Docker networking. Now let me clear all the containers on docker rm -f, and we can remove all the containers at once. This is my test VM, so I run this command to remove all containers at once. Now if I run curl localhost, I should not get anything. So now I want to use the host network. Okay, I mean I want to use the network of my machine to run the container. So the command would be docker network docker run. The host network is default. Okay, docker network ls. You saw that it is the default network. We cannot create a new network with the host driver. For instance, docker network create -d host driver, create a new network with this name uh, host net, and it is saying that only one instance of host network is allowed, which is default. So we don't have to create the host network standalone. We can create bridge networks. Multiple bridge networks can be created, but there would be only one host network, and it is created by default. Okay, and we can map our containers to this host. We can attach our containers to this host. Docker run minus itd minus minus network host. Okay, now host network is being used, minus minus name of the container, container1, and let's suppose busybox. No, I will use nginx. Okay, you can see that nginx is running now. Docker ps, this container is running. Docker inspect container1 and grep minus I network, and you can see that it is now using the host network, and it will not show us any IP addresses. uh, Everything is, it is not showing anything because it is using the host network, and it is running on all the IP addresses. For instance, if I have hundreds of IP addresses on the host network, I will get this application running on all those IPs. I have tested it and checked it practically. For instance, let's see what kind of IP addresses we have on this machine. Now I have this IP address. Okay, I can run uh, curl localhost colon 80. You can see I can see the output of the container. Similarly, I can use curl this IP address port 80, and I can see the output of the container. It means that this IP address is using the host machine's network. Everything that is on host network can be used by this container. And for instance, if I have this IP address of docker 0, and these IP addresses, I created these ranges, I can use curl this IP address colon 80, and you can see my container is showing the output on all the IP addresses of the host network. So that's how, guys, we can attach our containers to the host network, and then our containers start using the network resources of the host. That's it, guys, for today's networking lecture. I hope that you have enjoyed this lecture, and we discussed about the bridge network and how we can create different containers on one network, and we saw practically that how the containers can communicate with each other. So that was our second last Docker lecture. In the upcoming lecture, we will discuss about the Docker Hub and how we can push Docker images to the Docker Hub. And then we will have one or two lectures on Docker Compose. We must know how Docker Compose works and how we can write, or how can we work on a Docker Compose YAML file to spin up, to run multiple containers using the YAML file. That would be very interesting lectures on Docker Compose, in which we will run two applications, different applications, and using the single YAML file, we will run multiple containers. So I would really appreciate if you subscribe my channel and support me. More lectures would be coming on Docker, and these all lectures would be combined into a single course that I will share with you guys. If you have any questions, feel free to ask me in the comment section. I will watch you in the next video. Hey guys, I hope you're doing great today. This is our chapter number 17 and we are going to talk about the Docker Container Registry. Guys, we know that what a Docker image is. We were running Docker pull Ubuntu and we were pulling Ubuntu Nginx BusyBox images on our local VM. So you also know that now we can have our images on our local machine. But what happens if I want to share those images with my colleagues, with other developers, with software engineers to try to work on those images? That's where the Docker Container Registry comes in. The Docker Container Registry is a public cloud registry where we can host the images, the Docker images, so that those images can be pulled on other developer systems and those images can be worked on by other software engineers. So the container registry is a centralized point where we can store our Docker images. All those Docker images have proper tags and releases. We can tag our images according to the versions, according to the release, etc. So guys, Docker provides free public registry where we can host our Docker images. And apart from that, Google Cloud Platforms also have a container registry. Azure also offers a container registry and Elastic Container Registry is offered by AWS. But for your learning, you can sign up on Docker Hub and you can create a public or private repository, image repository, to push your images to the Docker Hub, and then you can pull those images anywhere in the world. Guys, you don't have to confuse with a registry and a repository. A registry is Docker Hub, Elastic Container Registry, Google Cloud Platform Registry, or Azure Container Registry. But repository is something else where you actually store your images. For instance, let me clear it with the following diagram, in which you can see this is, for instance, our registry. It is Docker Hub, okay, hub.docker.com, hub.docker.com. This is our registry where we are going to store our images. But how we can store those images? Those images can be stored in a public or a private repository, okay? Those repositories have the images with tags like my image, okay, this is my image colon version 1, version 2, version 3. That's how we tag the images. Now this is a public repository, okay, and this is a private repository, and the same thing, it can be my image colon version 1 colon version 2, and that's how we tag the images using the Docker tag command, and then we can push our images to the public and private repository. Now there is a slight difference between the public repository, this is my public repository, and this is my private repository. Well, as the name says, the public repository or the public images are available or accessible to anyone, but for private repository, the users must authenticate to access the images stored in the private repository. In the free plan on Docker Hub, hub.docker.com, we can create unlimited public repositories, but the free plan offers only one private repository, and we will create both public and private repositories. So now there is another question, that how we can push the Docker images to these public or private repositories, and how we can pull them on other VMs. Okay, so that's how it works. So for instance, I'm a developer and I want to have the images, the updated images on my VM. This is my VM or EC2 instance, okay? And I'm working on something and I want to pull the Docker images from my private repository on hub.docker.com, Docker Hub. So this is my private repository, okay? This is my private repository which stores the images. Private repository, my image colon version 1. For instance, I want to have this image pulled on my VM. So I would first run the docker login command. I have to log in to the Docker private registry, okay? I would need to run docker login, and I would have to provide the credentials, the username and password of my registry or repository. These are the credentials of Docker Hub. You have to provide the username and password. So when we run the docker login command, it will ask us for the username and password of Docker Hub, okay? Now we will authenticate our registry, container registry, which is Docker Hub on our VM. So username and password. Once we will log in on our VM, then we can pull the Docker images from our private repository. So I can run Docker pull and my image, and I don't have to give the username and password again and again. So that's how, guys. First we need to log in, and then I would give the username password, and then I can run the docker pull command. For instance, I'm working on this image and I have made some changes, and now I want to push the updated version of the same image in the private registry or private repository, which is my image version 1. Then I would use the docker push command, docker push command, and I don't have to give the credentials again and again. But if I am logged out from my VM and I would run the docker pull or docker push command, then it would give us the authentication or authorization error. And now, for instance, I have the updated version of my image. It would be pushed to this repository, and we would have the updated version of the image with updated tab. So that's how, guys, we need to log in to Docker Hub or ECR or Azure Container Registry using the credentials. When we are logged in, then we can run the docker pull command to pull the images. We can run the docker push command to push the updated images. So another thing I would like to repeat again, that why do we need the private repository? Because our image can contain the source code, the binaries and dependencies that we don't want to have publicly available. So that's why, from security point of view, we should not share our code, our images to anyone in the public. So the recommended process is to create only the private repositories where you can store your images on Docker Hub. So from our learning perspective, we are going to create a free account on Docker Hub, and we are going to push and pull our images in our private repository. So let's get started in our lab session. Okay, guys, now I'm going to log in hub.docker.com. So before that, we need to create an account on hub.docker.com. So this is the URL. You can by the way, search on hub, Docker Hub, and this first container image library, this URL, and you can click on that to log in to sign up on this free account. Okay, and we will have this screen. Click on the sign up button, and your email, my my email is devopsmolvi@gmail.com, and the username and password here. So you can sign up on dockerhub.com, and once you click on the sign up button, you will have to verify your email address, and once verified you will be able to create repositories on Docker Hub, and also you can create public or private repositories on hub.docker.com. So it is required to create a free account. Now I will log in. So this is the password, and I would log in, saving the password. So now you can see create a repository, push container images to a repository on Docker Hub. So we are going to create our first repository, and this namespace, I would use the same namespace as DevOps Molvi. And now the repository name. So now I would create the repository name as web images. For instance, these are web images, and you can see that it is saying using 0 of 1 private repositories. Okay, and you can see the plans here. For personal or free use, we can only get one private repository. Okay, and these are other plans for your teams. If you want to get these plans, you have to pay $9 per seat per month, and this is pro plan, in which we have to give $5 per month. And you can see we can have unlimited private repositories, but here in our personal free plan we can only get one private repository but unlimited public repositories. So you can create unlimited public repositories, but your images would be public. And so for our learning, we are going to create only one repository, and this would be private, and you can see it would be only visible to you. So let us create our first repository. Okay guys, I've created it, and now it is also showing us the command to push the images. Now this would be the command docker push, that our images must have this tag. Okay, DevOps Molvi / web images, and tag name version 1, version 2, or release name 1.0.00, etc. So now we have created our repository. Now let us log in to our VM so that we can push our first image on our repository. So I would log in, and I'm in my VM. Clear the screen. Docker images, I have these images. We are going to push this minimum image so that we can have luxury of time to pull and push multiple images. I would tag this image according to the repository name. This is really important. We must have the same tag to push the images to this repository. If the name or the tag do not align with each other, we cannot push the images into that specific repository. So you guys can see that this repository is empty. Push some images to see them appear here. So we are going to push the images, and I would use this name to tag my images accordingly. Docker tag busybox, okay, the current image, and the image you are going to tag. For instance, this is our version 1. Okay, now another separate image would be created. Okay, we now have 3 images. Now this is our image, and we can push this image to our private repository. How? Docker push and version 1. Now it will ask us for the password. Okay, you can see that denied, requested access to the resource is denied. I explicitly run this command so that you can see for pushing the images to our private repository needs authentication. Okay, now I will log in to the Docker Hub from my VM, Docker login. It says that login with your Docker ID or email address to push and pull images from Docker Hub. Okay, now I will use the username DevOps Molvi and the password. Okay, guys, we are now logged in, and you can see it is saying login succeeded. So now we are able to push our images to the Docker Hub repository. I will use Docker images. Now you can see we can push this image. Docker push command would be used to push the images. First, we tag the image according to our repository name. Okay, you see that we are using the Docker tag command and our current image and the new tag, new image name. Now we are going to push this image to our repository, and it should not give us the access or authentication error because we are logged in, from our VM, and we shared the credentials, we gave the credentials, username and password. Now we are going to push our first image in our Docker repository, private repository. My net is a bit slow, and that is why it is taking a little bit time. I think my internet was slow, that is why I got this error. So that's why I tried to push the image again, and it says that the layer already exists, so it means that the image has already been pushed. Now we will refresh and we'll see whether we have the image or not. All right, guys, we can see that our image has been pushed to the repository, and you can see it is busy box, and these are the information regarding our image. So now let's suppose I am using another version of this image has been updated, and now we have another version of this image. So for instance, Docker tag busy box, and I will use DevOps Molvi web images colon 1.0.1. So that tag is a bit different. Okay, now I will push this tag again to our repository 1.0.1, and it should not take much time to push the image because there is already a layer exists, and we must now have a new tag for this Docker image. Okay, web images, and this is our private repository, and now we can see the tags here as well. Here the tags option, and all the tags would appear here. You can see we have version 1, and then we have 1.0.1. so that's how, guys, we can push the images. Now for instance, I would remove these images. Okay, Docker images, and I will remove these images, Docker RMI. I will remove this image as well, version 1, and I will also remove this image 1.0.1. Now we should not have these images anymore on our VM. Now I want to pull those images, and let us suppose that I am logged out. Docker logout command, I have been logged out. But for pulling your images from the private repository also requires authentication. Okay, now I'm running docker pull this command to pull the image from my private repository, and you can see that it is saying you are denied because you have to log in, because I logged out. Now I would log in back, Docker login, and I will log in again, DevOps Molvi, and password. Okay, now I am logged in. Now I can pull the images on my VM. For instance, this is a remote VM, any other VM. So we can log in using the docker login command, and now we can pull the images from our private repository, and you can see our image has been pulled. So for instance, if I want to pull any other tag, docker pull and version 1, so we can pull this image as well. So docker images, I am having all these image tags here, and that's how, guys, we can log in to the Docker Hub repository registry from our VM, and that's how we can tag images and push and pull images to and from Docker Hub. So that was a quick and short tutorial to let you know, guys, how we can store our images on Docker Hub. The case is similar whether you are using Azure Container Registry or Elastic Container Registry from AWS, because we have used it as well. And you just have to use the docker tag command to tag according to the repository name. Now, for instance, this is my repository. I must have this tag for my images, and I must tag my images according to the repository name to push the images or pulling the images from this repository. So the process is almost the same. You must have the tags similar to the repository name. You have to log in on your VM using the docker login command. Once you share the credentials, you can pull or you can push the images from or to your private repository. So guys, we can have only one private repository, and recommended way is to create private repositories on Docker Hub, since I have only free plan. So you can also create a free account on Docker Hub and create a private repository to push and pull the images. In the next chapter, we are going to start with Docker Compose. I hope that you're watching my earlier lectures on Docker. It is going to be completed soon, and we will have a full-fledged Docker course uploaded on my YouTube channel. I would really appreciate if you subscribe my channel and support me. I will watch you in the next video. Hey guys, I hope you're doing great today. Well, today we are going to talk about the top 50 Docker interview questions and answers. So without any further ado, let's start with Docker interview questions. Alright guys, the question number 1 is, what is Docker and why it is used? I mean, why we use Docker, why the IT companies and organizations use Docker? And the answer is straightforward and simple. The Docker is an open source platform for developing, shipping, and running applications. We run applications in our containers, and that's what Docker is used for. And it enables you to separate your applications from your infrastructure so you can deliver software quickly. The purpose of Docker is to deliver your software quickly, and that's why Docker is one of the major tools in automation and CI/CD pipelines. And with Docker, we can also manage our infrastructure in the same way we manage our applications. So Docker is a containerization tools, and it is used to containerize our applications, and it makes the software delivery more fast and speedy. Okay, question number 2. What is containerization? We are going to start with some basic questions, and then we will move towards some advanced questions as well. And guys, this is part A. This is our first part of Docker interview questions, and there would be another part coming with more 50 plus questions. What is containerization? It is a type of virtualization in which all the components of an application are bundled into a single container image. Just like we see ship with containers, all containers are isolated and packaged with libraries and binaries, and that's what containerization is used for in computer science and computer engineering. And it is a virtualization type, and we can run in isolated user space on the same shared operating system. I mean, we have the same space, we have the same operating system like Linux, and we can run hundreds of containers, isolated containers on a single server. And that is what containerization. We pack our application, and one of the most beautiful things is that we can have Java, Node, Python, Spring Boot, or any application running at the same time on a single operating system with the help of containerization. So that is what containerization is. Question number 3: what is the difference between containerization and virtualization? We use virtualization to build, to install, to run virtual machines on a single server, right? Virtual machines, VMs using VMware or any other hypervisor. It is a bit different thing, but containers are a little bit different from virtualization. And let's see what is the answer. Virtualization allows you to create virtual machines, right? This is simple. We can create virtual machines on a single server from underlying hardware resources. That is the key difference, actually, using an abstraction layer known as a hypervisor, like Hyper-V or VMware. Guys, this is our server, and we install a layer on it, which is known as a hypervisor. It can be VMware ESXi, Hyper-V, Zen, etc. Those hypervisors are used to create virtual machines, and each virtual machine is a separate operating system, and it uses the underlying hardware. Whereas containerization is different form of virtualization in which an application is bundled along with its code, libraries, dependencies, and everything else needed for it to run inside a component known as a container. And the underlying hardware resources are not used, but it virtualizes the operating system. Okay, that is the key difference. And our question number 4. Now this question is related with our previous question. Now we use containers, and who manages all those containers? Like we have hypervisor, VMware or Hyper-V, and hypervisor manages the VMs on a single operating system, single server. Now who manages the containers on a single server? And the answer is the Docker engine. But what is Docker engine in a bit detail? The answer is Docker engine is a client server application that provides the core functionality for building, running, and managing Docker containers. Just like we have a ship and its engine, the engine runs the whole ship. We have Docker engine which runs the whole containers. It manages, it builds the containers, pushes, pulling images, all that is happening. It is used, it is to say, Docker engine, it is the core component, the core engine which is managing all of that happening. It consists of a Docker daemon and a Docker CLI which communicate with each other. The Docker engine manages the container lifecycle, networking, storage, and other essential aspects of the Docker platform. So without a Docker engine, obviously there would be no Docker containers. And there are two more main components. One is the Docker daemon and the other is Docker CLI. You guys saw that we have used the Docker CLI to build and run our images into the containers, and all of that is being managed by the Docker engine. Question number 5, what are the three primary components of Docker? We have already discussed. If you have watched my What is Docker lecture, you can easily learn about those three major components. The one is Docker client. I said it is you are running any command like docker run Ubuntu. You are the client, and you communicate with the Docker host. Docker host runs on the VM, and the Docker uses the Docker build and run procedures. Docker host, where our Docker is installed, and our containers are managed by the Docker host. And Docker engine is the back. The guy who is controlling all of that. All of that is Docker engine. Docker host, where our Docker engine is installed, and it is a service that allows you to host Docker containers. The registry, after all, we build images and we run those images into containers, and Docker images are stored in a registry, and we know that the common and free registry to work with is hub.docker.com, which is Docker Hub. We can create public and private registries to host our images. Now, what is a Docker image? Okay, a Docker image is a lightweight, standalone, and executable software package. It is an artifact. You can say it is a complete, you can say a little minimum operating system. It is, and just like we have ISO images for the operating systems like Ubuntu and Debian, it is a minimal operating system, or a binary, or an artifact which contains everything needed to run a container. And it contains the code, runtime, libraries, dependencies, and system tools. Question number 7, what is the command to pull a Docker image? Really simple. Docker pull command is used to pull any image from our registries. If it is a public registry like Docker Hub, we can use Docker pull Ubuntu with latest tag, and Docker pull is the command. Just like Docker pull, we use Docker push to push the images to the Docker Hub registry. Question number 8, where Docker stores all of its data on the host machine. Now we are getting started with a little trickier questions, and the answer is Wadlib Docker. We discussed it in our Docker volumes lecture in detail, because we were creating volumes and we saw all those volumes are stored or created in Wadlib Docker volumes folder. So Docker stores all of its data in Wadlib Docker, and data can be like volumes, networks, and images. Question number 9, can we use a single Docker image to run multiple containers? And the answer is yes, we can. We can have a single Docker image and we can run multiple containers with that single Docker image. I have shared the example of Nginx. Now we are running two different containers, web server 1 and web server 2, using a single Nginx image. Question number 10, what are the Docker image layers? Guys, we discussed this in our Dockerfile section, and in which each Docker instruction, each instruction in the Docker file is a separate new layer. So basically a layer or an image layer is a change in an image. For instance, we specify an instruction like from, run, copy, etc. in our Docker file. It creates a new layer, and the previous image to change, thus creating a new layer. Each instruction is a new separate layer. Question number 11, what is the difference between a Docker image and a container? And we know that Docker image now. What is the difference between an image and a container? So an image is the snapshot of the container, right? Just I told you that it is a minimal operating system, you can say, or an artifact or a snapshot of a container. Image is the set of layers, and the running instance of that image is a container. The image is the recipe, and the container is the cake. Okay, you can make as many cakes as you like with a given recipe. So I found it from Stack Overflow, so I shared it for you guys. You can now, I hope you can relate. So we can have multiple containers of a single image, and image is the snapshot, and container is the running form of that image. Question number 12. Can we delete an image if there is a running container of that image? No. We need to delete the container first, because an image is bound with that container. So we have to remove the container in order to remove the image. Question number 13. A common error after we install Docker: got permission denied while trying to connect to the Docker daemon socket. What's the reason of this error? It means that our user, for instance, I am installing Docker with DevOps Molvi user, and we did it in our installation lecture, and I have created a separate video of this error. You can check it on my channel. And if our user is created used to install Docker, it is not authorized to run Docker commands, and we have to grant it the necessary permissions. What are those permissions? We need to add our user to the Docker group with the following command: user mod, user modify -ag, and G stands for group, Docker group, and your user. So user mod command is used to add your user. Now replace your user here, and your user will be added to the Docker group, and then you need to log out from your terminal and then log in back, and this error will be fixed. Question number 14. What is the difference between a container layer and an image layer? Guys, this is a really conceptual question, and we discussed it in our Docker volumes section. When a container is created from an image, Docker creates an additional container layer on top of the image layers. We know that we use Docker build to build an image, and that Docker build reads the Docker file, and each instruction is treated as a separate image layer. But what is a container layer? It is a read-write layer on top of the image layers, and it stores ephemeral data which is generated by the container during the runtime. That data lasts only when the container is running. If the container is removed, we lose the data. So the container layer is actually a read-write layer which contains ephemeral data or temporary data that is required at runtime when the container is running. Question number 15. If we remove a container, what happens to its data? And the data inside the container is lost because we are not binding any volumes to it. Okay, when we have a volume, then our data is saved. But if we are not attaching any volume or a bind mount, then if we remove the container, the data inside that container is lost. Question number 16. What are the options of persistent storage and in Docker? Now we are coming towards data storage in Docker, like Docker volumes and bind mounts. So these are the two options: volumes and bind mounts for persistent data storage in Docker. Question number 17, and it is continued version of the previous question. We have to define the difference between volumes and bind mounts. So volume is, it creates a new volume under var lib docker volumes directory. Okay, so volume creates a new volume under the varlib docker volumes directory and persist container data after a container is deleted or stopped. Now we do not have to worry about data because our data is saved inside the volume. And bind mounts uses the bind mount, and a file or directory from the host machine can be mounted onto the container. In Docker volumes, we create a separate volume, and as discussed, Docker volumes are more resilient. That was our previous chapter. And bind mounts, we can mount a folder or directory directly into the container. But since now volumes are preferred, so we use Docker volumes to store our data. Question number 18. Why volumes are preferred over bind mounts? Okay, so volumes are completely managed by Docker. That is one of the reason. And the bind mounts are dependent on the directory structure and OS of the host machine. That is actually the core reason. Volumes are independent, and bind mounts are dependent of the operating system and the directory structure of the operating system. So we should create volumes because volumes are more resilient and independent of the operating system. Question number 19. What is the default volume driver? And the answer is local volume driver if there are no volume drivers specified. Question number 20. Which command is used to create a volume? And the answer is straightforward and really simple. Docker volume create and your volume name. That command creates a volume. Docker volume ls lists down the volumes. Docker volume removes rm, removes the volume, etc. So Docker volume create and your volume name. Our volume would be created, and then we can attach that volume to any container. How would you mount the volume to a container? Basically, we are talking about the command, how we can attach a volume to a container. And the command is docker run -d detach name of the container minus or hyphen mount. That is actually the core syntax. You should focus on that. Hyphen mount source, the volume name, and comma target the directory in the container, inside the container where you are going to mount your volume, and the image name. It will create a new container with web server 1 name, and our volume, my volume, would be mounted on user share nginx html directory. So that's how we can mount a volume to a container. Question number 22. Can we remove a mounted volume to a container? And the answer is no. A volume which is mounted cannot be deleted. Only an unmounted, unused volumes can be removed. Okay? When a volume is mounted with a container, obviously the container is running and it needs that volume because it is storing its data inside the volume. So how can we remove a volume when the container is running? So the other solution is to remove that container, and then volume can be deleted. Question number 23. Can we mount a single directory to multiple containers? And the answer is yes, we can mount a single directory to multiple containers at the same time using bind mounts. And we can also mount a single volume with multiple containers at one time. Question number 24. What is a Docker file? It is a blueprint of a Docker image. Okay? And it is a plain text file which contains a set of instructions which are used by Docker build for building a custom Docker image that is most suitable for our application. Like we discussed, we built a node application and we containerized that node application using the Docker file, in which we had multiple instructions like from, copy, run, expose, cmd, entry point, etc. So that is Dockerfile, which is used to build custom Docker images. Question number 25. Please share a couple of Dockerfile instructions and what they are used for. And I have mentioned only a couple of instructions like from, and it creates a layer from the base image, and copy a file from host into the image, run command, any we can run any commands inside the image, cmd, which process should run in the container when the container starts, which process should run. So expose, to expose any port. Entry point is also like cmd to run any process inside the container. And add, to add uh, any file using the remote location or a url. So these are some of the major Dockerfile instructions. Each Dockerfile instruction is a separate new layer inside the Docker image. Question number 26. Can we have multiple from instructions inside a single Dockerfile? The answer is yes. Why? Because we used multi-stage builds, right? We used multi-stage build, and we had multiple from instructions. And the answer is yes, we can have multiple from instructions to build a single image. It is known as multi-stage builds in Docker. Question number 27. What is the difference between copy versus add commands? Both commands are both are Dockerfile instructions. First of all, we should know that copy and add are Dockerfile instructions, and both serve the same purpose of copying files, but there is a slight difference. Copy is more straightforward and recommended for general file copying. If I want to copy package.json or any file, I can use copy instruction. On the other hand, add instruction has additional capabilities such as extracting tarballs and copying remote URLs. That is more powerful because, for instance, if I am using or downloading any plugin and it is in the archival form, I mean .tar, .gz or .zip, I can use add to download to get that URL from any remote location, and then it is extracted inside the image. When we run into container, we have that tar archived, and that is what add command is, add instruction is used to it extracts the tarballs, and also it can be used to copy from the remote URLs. Question number 28. What are the best practices to reduce image size in Docker? When we use Docker build command, it reads the Docker file to build an image. It can be 500 MB or 800 MB or 1 GB. And when we have thousands of Docker images, it can cause disk space issues. So we can reduce the image size, and the best practice is to use a minimal base image, like we use Alpine, which is just 5 MB or 6 MB, and consolidate commands in a single layer. What is that? This is something you must know. For instance, if I am running run apt update, that is a separate instruction. I am using run again and again and again. I am using 100 run instruction. It will cause the image size to be bigger. Remove unnecessary dependencies and files, and leverage multi-stage builds. If we don't use any dependencies, we should remove them. We should not use them in our final form of the image, and we can use multi-stage builds to reduce our image size. Question number 29. That is the previous question in which we talked about consolidate commands in a single layer. I am creating a separate question for that, which is multiple run versus single chained run in Dockerfile, which is better. So multiple chained single chain run in Dockerfile is much better because each run instruction creates a new layer, and we must minimize the image layers, okay, to reduce the image size. So that is why a single chained run is better. I can use a single run instruction, and I can use multiple commands in that single instruction: apt install abc, apt install, so on. So that would be a single chained run instruction, and only one image layer would be created, so our image size can be reduced with this practice. Question number 30: what is the difference between cmd and entry point? And the answer is entry point is the process that is executed inside the container. And entry point and CMD serve the same purpose. Both are used to run a process inside the container. And the key difference is that CMD is the default set of arguments that are supplied to the entry point process. Entry point is superior. So it means that when a Docker file is using the CMD and entry point instruction at the same time, the output of CMD would be passed to entry point. It always, in Docker, that entry point has a superiority, has a priority. Entry point instructions are given more importance as compared to the CMD instructions. So when in a single Docker file, if there is a CMD instruction and an entry point instruction, our container will have the instruction which is entry point running inside it. So entry points are always superior. Question number 31: what are the Docker object labels for metadata? Basically, labels are the mechanism for applying metadata to Docker objects, such as naming containers, images, local daemons, networks, volumes, and nodes. So Docker object labels are used to for all these naming conventions. Question number 32: if I want to remove all Docker images at once, what would be the command? Now, this is actually a merger of two commands. This part, uh, sorry, this part would get the image IDs. Okay, Docker images minus a minus q, both switches, and this command is a separate command which gets the image IDs. Okay, you can run this command separately, and all those IDs are then removed forcefully with Docker remove image commands. Okay, that is how this command works. And similarly, if I want to remove all the Docker containers at once, we have this command in which this Docker ps minus a minus q would get the container IDs, and all those containers are forcefully removed with Docker rm minus f command. Question number 34: if I want to remove everything like volumes, images, containers, networks at once, what would be the command? That is actually a very dangerous command, and it is Docker system prune. It removes everything. It removes your Docker infrastructure. That's it. Nothing is left. Networks, volumes, containers, images, everything is removed. So make sure to avoid this command on your dev servers, QA, or production servers. However, if you want to test it, you can test and check this command on your local VM. By the way, it is a really dangerous command. Question number 35: how can you update a container without losing data? I want to update a container, but I want to have my data saved. I don't want to lose the data. What are those steps? First, we need to make sure the data is in the Docker volume. We must have a Docker volume, and that volume must have the data, and it is attached to the container. So we will stop the container, and we will stop the container with the Docker stop command. and we will pull the latest version of the Docker container image. Okay, because we are updating our container, so we must have the updated version, the image. Okay, and we can use the docker pull command to pull the Docker container image. Now we need to start a new container with the updated image, and we can mount or map the volume with that running container. And we can verify the new container is function correctly and the data is still intact. So guys, if we have Docker volumes, our data would be saved, and we can uh, mount this volume to the new updated container. Question number 36. How can we secure the containers? We have Docker containers running in production and we want to secure them. So there are four major measures that we should take using the trusted base images from reputable sources. Whether we have our custom images, or we should pull the trusted images from reputable like hub.docker.com have verified images. Our base images must be verified and have no malware or anything like that. Regularly updating Docker and the underlying host system with security patches, scanning container images for vulnerabilities and using security tools, and monitoring container activity and logging for security analysis. So these are four major steps to secure our containers. Question number 37. How can you configure automatic container restarts in Docker? If I want to reboot my server, my VM, host machine, but I want to have all my containers up and running when the machine boots up, so there is a switch we can use in the run command, which is hyphen hyphen dash dash restart is equal to always. It means that our container will always restart if our host machine boots up. Question number 38. What is a Docker registry? Docker registry is an application that manages storing and delivering Docker container images. It is the storage point where we store our Docker images. And Docker also has a free public registry, which is Docker Hub, and we can use it to host our custom Docker images. Other registries are like AWS ECR, Elastic Container Registry, to host images. We can use GitHub registry as well for our Docker images. Question number 39. What are the steps to push a Docker image to a private registry? If I have a private registry and I want to push the Docker images to that registry, first I would have to log in using the Docker login command, and it will ask for the username and password. Then I must tag my Docker images according to the registry name. So it should be like username my repo. That, for instance, if my registry, public registry or private registry, has DevOps Molvi web images, okay, so the Docker images must be tagged according to that name. My Docker images must have DevOps Molvi have hyphen, my web images, my anything you can name. So make sure that the tags of your images must resemble or must align with the registry name. So we can then use Docker push command, Docker push username my repo, and this is the tag, image tag, and our images are pushed to the Docker images registry. Question number 40. Where are the Docker credentials stored in Linux? For instance, if I run Docker login command, okay, it asks for username and password. and where those credentials are saved, those credentials are saved in the user's home directory, in which there is a hidden docker directory which contains config.json file where our credentials are stored. Question number 41. How can we monitor our Docker infrastructure in production? And uh, there are tools provided by Docker, which and there are tools provided by Docker like Docker stats and Docker events to monitor Docker in production. And Docker stats provides CPU and memory usage of the container, whereas Docker events provide information about the activities taking place in the Docker daemon. So both tools are used to monitor our Docker infrastructure in production. Question number 42. What is the difference between Docker and Kubernetes? Uh, and we are going to learn a lot about Kubernetes in our upcoming lectures. Docker is used to package applications into containers, while Kubernetes is used to orchestrate and manage those containers in production. So Docker ships and deploys application on a single node, and Kubernetes manages applications across a cluster of nodes. When we have hundreds of Docker containers, we need a container orchestration tool which manages all those containers, which looks after all those containers, and Kubernetes is used for that. Question number 43. Why should we use a .docker ignore file? Just like .git ignore, this file is in Docker lets you specify files or directories that should be ignored when building an image, and it prevents unnecessary or sensitive data from being included. Just like we use .git ignore, and all those directories and folders are ignored while we push anything to our. So just like .git ignore, we can use .docker ignore to ignore anything that we don't want to be pushed. Question number 44. We run a simple docker run Ubuntu command. What happens behind the scenes? You just run a docker run Ubuntu. What is going to happen? It will run a container of the Ubuntu image, but first you are the client, you have run this command, and this client will communicate with the host via an API. The host which is running the Docker daemon, Docker engine. The host checks for the client request and communicates with the registry and pulls the required image. Now we are using Ubuntu, we can use Nginx, etc., and that exact image would be pulled from the registry, and then the Docker daemon runs the Ubuntu image into a container. That is what be going behind the scenes when we just simply run a docker run Ubuntu command. First, our client talks to the Docker daemon. The Docker daemon checks the registry and pulls the required image. We get that image on our host, and then our Docker daemon runs this image into a container. Question number 45. What is the command to see all containers running, paused, stopped, or in the exit state? I mean, I want to see all the containers, whether they are paused or in exit state or running or stopped. So the Docker ps-a, it will list and show all the containers, whatever their current state is. Question number 45. What is the command to see all the containers running, paused, stopped, or in the exit state? And the answer is Docker ps-a. The -a option shows all the containers, whether they are running, whether they are stopped, or in the exit state or paused. So that command, Docker ps, shows only the containers that are in the running state. But if you want to see all the containers which are stopped or in the paused or exit state, you need to run docker ps -a. Question number 46. Can we run containers in the cloud? If so, how? And the answer is yes, we can run containers in the cloud using popular container as a server using popular container as a service platforms like AWS Elastic Container Service. ECS is one of the key services, container services offered by AWS if you want to run containers in the cloud, and Azure Container Instances and Google Cloud Run are the three different services provided by the three different cloud providers if you want to run containers in the cloud. Question number 47. How can we check each and every detail about our container? For instance, I executed a command, docker run Ubuntu. I am now having a running container of Ubuntu, and I want to inspect everything. I want to see everything about that container. The command would be docker inspect and container ID or container name. And docker inspect produces, it shows a JSON file or JSON format in which we get all the details of that container. Its storage, its network, and which image it is using, and other details about the container. So docker inspect, we can use it for volumes, docker inspect volume and volume name, docker inspect network and network name, docker inspect image, etc. So we can use docker inspect with all other like volumes, networks, and other than containers. Okay guys, our third last question. What is the use of the docker save and docker load commands? And the answer is a docker image can be exported as a .tar archive. Okay, and we did it in over 50 docker commands in 50 minutes. If you remember, I have a lecture on that as well, in which we use this command and exported a tar archive of a running container via the docker save command. Now we can use the docker save to get the tar archive of any image. Then the exported docker image can be imported to another docker host via the docker load command, and we can use this image. Now we have the image, it can be pushed to the public registry or our private registry, and then we can pull it and run on any host. So that is the difference between docker save and docker load commands. Docker save commands helps us to export a tar archive, and docker load command is used to load or import that tar. Question number 49, which is our second last question, and it says that what do you know about distroless images in Docker? Now guys, we saw multi-stage builds in Docker. We used multi-stage builds. I have a full lecture on that as well. We used multi-stage Docker builds and tried to reduce the image size of our Docker image. Distroless images are the minimal images which contain only your application and its runtime dependencies, and their purpose is to reduce the image size as well. So they do not contain any package managers, shell, or any other programs. Okay, so distroless can be used to reduce the Docker image size. Okay, for our final question, which is question number 50, and it asks why multi-stage Dockerfile is required. Why do we need multi-stage Dockerfile? And by the way, guys, you must know that in multi-stage Docker files, we can have multiple from instructions. We can have multiple base images to produce, to get the final image, which should be in very less footprint, very less image size. And when building complex and large applications where the build process requires a lot of dependencies that are not needed at runtime, we use Docker multi-stage Docker file. For instance, we have a Java or Spring Boot application, and we have to compile a lot of dependencies, so we can do all that stuff in the initial stages. And multi-stage Docker file can be in one or more, can be in two or more stages, minimum two stages. So each stage has a separate from instruction, and we use the artifact, we use the output of our first stage in our second stage. So we can ignore the tools, so we can ignore the dependencies or the build tool in the final part of the image. So our final image should not have all those dependencies, all those build tools, and thus it saves a lot of time, and also it saves a lot of disk space consumption by the Docker images, and it is used in large and complex applications where build dependencies and tools take a lot of time. So we can use multi-stage Docker files, and we can produce optimized Docker image using multi-stage Docker builds. Alright guys, so that is for today's lecture, and I will definitely share these questions, this drive with you guys in the description. The link would be in the description. That is why I request you to please subscribe my channel, and I will share another 50 Docker interview questions and answers so that you can crack any questions regarding Docker in any interview. These questions are very beginner friendly, I hope, and I will be covering as soon as we proceed towards any advanced stuff. We will have advanced interview questions and answers. So we have been covering all the basics. We covered about Linux, and now we have covered about Docker as well. So if you have any other Docker interview questions, please make sure to share with those questions with me, so I can put them in my video. And make sure that you subscribe my channel. This is the only way you can support me at this time. I will see you in our next lecture, which is on Docker networking, and then we will start with Docker Compose, and we will cover basics of microservices and Docker Compose YAML file. Something super exciting coming on the way. I would like to request you again to subscribe my channel and share the videos among your friends. I will see you in the next video. Take care. Bye.